The Sun, our star, breathes in a way that is not like lungs rising and falling, but in streams of charged particles that flow softly across the solar system. This breath, known as the solar wind, moves quietly but steadily, filling the vastness between planets with invisible energy. Each atom that leaves the Sun's surface carries warmth, motion, and a hint of its ancient fire. Though it races at hundreds of kilometers per second, its presence feels calm, an endless sigh from the heart of light itself, whispering to every world it touches. If you could drift in that space, suspended beyond Earth's atmosphere, you would not feel wind as we know it. There would be no air to move your hair, no sound to reach your ears. But the Sun's breath would be there all around you, pressing ever so lightly, particle by particle. It is a river of ions, mostly hydrogen and helium, crossing billions of kilometers. It shapes magnetic fields, stirs tails of comets, and paints the skies in northern lights when it meets our planet's shield. Every second, millions of tons of solar material leave the Sun, but its body remains full, its surface bright and burning. The flow is balanced, gentle in its enormity. This ceaseless motion is how the Sun speaks to space, how it keeps the solar system awake and alive. Yet from the serenity of Earth, all of it feels still. We see only the sunlight that warms our skin, unaware of the unseen storm that glides by, weaving patterns through empty cosmic silence. The solar wind begins at the corona, the Sun's ethereal outer layer, glowing at millions of degrees. There, the heat is so fierce that atoms break apart into free-floating ions and electrons. These charged fragments escape the Sun's gravity, racing outward like sparks that never fade. They do not scatter chaotically but move in streams, guided by the invisible force of the Sun's magnetic field, stretching and twisting across unimaginable distances. Sometimes, that gentle breath turns rough. Solar storms erupt when magnetic lines tangle and snap, releasing vast bursts of energy. But even in quiet times, the solar wind never stops. It moves outward in waves, carrying whispers of the Sun's inner moods. Scientists studying it often describe it as a kind of heartbeat, steady, rhythmic, ancient. Each pulse of plasma tells a story of what the Sun is feeling, a pulse that Voyager and other spacecraft have learned to sense as they travel outward. If you could listen to it, not with ears but through instruments that feel the flow, you would hear the hum of a living star. The wind's patterns shift over time, slowing and strengthening as the Sun's magnetic cycle turns. Every 11 years, the poles of the Sun flip, changing the very direction of this great breath. Yet even through these changes, it never ceases. It is constant in its motion, like a guardian that never sleeps. As the solar wind expands, it forms an invisible bubble around our entire solar system, called the heliosphere. This is the Sun's personal realm, a vast cocoon of charged particles and magnetic currents. Inside it, planets, comets, and asteroids float in the Sun's protective glow. Beyond it lies interstellar space, a region where the breath of other stars begins to mingle. The boundary between them is delicate, shifting, and mysterious. It is where Voyager once drifted, feeling that transition. Closer to the Sun, the breath is warm and dense, flowing swiftly around Mercury and Venus. Near Earth, it becomes more gentle, spread thin by distance. Yet even here, its power can be felt. When it strikes our planet's magnetic field, it stirs the upper atmosphere into shimmering veils of color. These auroras are the most beautiful signature of that invisible motion, a quiet message from the Sun, written across our polar skies. Imagine now, the Sun's breath stretching further, past Mars, past Jupiter's swirling storms, past the frozen orbits of Neptune. Out there, its power fades, slowing as it meets the cold, thin gases drifting between the stars. But it still pushes outward, maintaining the boundary of the solar system. That boundary is not a wall but a transition, a place where the Sun's strength meets the universe beyond. Voyager called it the heliopause, the farthest reach of the Sun's breath. In the deep calm of space, this flow carries dust and particles outward like tiny ships in an invisible sea. Even though space seems empty, the wind keeps shaping it. It bends comet tails, nudges cosmic rays, and guides the dance of planetary magnetospheres. The solar wind is both sculptor and storyteller, defining the shape of our cosmic home. Without it, the planets would drift unprotected through interstellar storms. The Earth owes much of its safety to this breath. It acts as a shield, pushing back radiation that might otherwise strike our world. Our magnetic field joins in the defense, deflecting most of the charged particles away. Together, Earth's magnetism and the solar wind create a balance, sometimes fierce, sometimes tender. When they meet just right, they create the glowing curtains of the aurora, the soft songs of the magnetosphere, and the invisible pulse of life that travels through the ionosphere. Scientists once thought the solar wind was gentle but static. It took decades of exploration to reveal its personality, its calm, and its chaos. Spacecraft like Parker Solar Probe and Voyager have recorded its fluctuations, showing how it changes across time and space. Near the Sun, the wind is wild and heated, full of turbulent eddies. Farther out, it cools and smooths into long, even streams, as if the Sun's breath itself grows calmer with age and distance. The solar wind tells a story about connection. Every molecule that leaves the Sun eventually touches something: a planet, a dust grain, a field line, or the edge of the heliosphere. Through this invisible link, every world in our solar system feels the Sun's presence. Even Pluto, so distant and cold, feels the faint pressure of that eternal flow brushing against its icy plains. The Sun's breath binds everything it created, like a thread of light woven through the dark. In times of solar quiet, the wind is steady and mild, giving space a sense of calm. During storms, however, it surges with sudden energy, blasting out waves of charged particles that can disrupt satellites and communications. Yet even then, there is a strange beauty in its wildness. It reminds us that our star is alive, breathing, shifting, pulsing with heat and power. That vitality keeps the system in motion, reminding us of the living rhythm at the center of it all. When we speak of sunlight, we often think of brightness. But the solar wind is sunlight's shadowed twin, the unseen aspect of the same force. It does not glow, it drifts. It cannot be seen, it can only be measured. And yet, it carries the Sun's energy in a purer form, untouched by reflection or absorption. It is the Sun's whisper to space, saying, "I am here, still breathing, still giving." To understand this cosmic breath is to understand our own fragility. Everything on Earth, every breeze, every ocean wave, every flicker of the aurora is subtly tied to that flow. The balance of radiation and wind determines how our planet's magnetic shield behaves. It affects how our atmosphere evolves, how satellites orbit, and how we detect cosmic signals. We are wrapped, always, in that quiet energy. Far beyond where the planets roam, this breath begins to slow. The Sun's strength fades, and the opposing pressure of interstellar gas begins to resist it. There, the wind compresses and warms, forming a soft boundary, a place where the Sun's influence ends. Voyager once crossed that edge and felt a sudden shift, as if moving from one ocean to another. Scientists called it the heliopause, but in poetic sense, it is the outermost sigh of the Sun's breath. Even beyond that border, the traces of solar wind continue to drift outward, merging gently with the interstellar medium. The Sun's particles may one day touch other stars, mixing with their own winds, forming vast cosmic currents. In this way, the breath of our Sun becomes part of the larger breathing of the galaxy, a pattern that repeats among billions of stars, each exhaling into space, creating a cosmic rhythm that never truly ends. And so, when you look up at the sky and see the Sun glowing quietly above, remember that it is not just light that reaches you. It is motion. It is energy. It is a gentle tide that never stops flowing, even through the coldest night of space. The solar wind, soft and invisible, is the heartbeat of the system that made us. To listen to it is to hear the universe breathe. In that breath lies both creation and calm, the power to shape worlds, and the peace to let them drift. The sun's breath is both wild and tender, fierce and soothing. It moves across billions of miles without sound, carrying the warmth of a distant fire to every corner of its family. And though we cannot feel it directly, its presence touches us all, as softly as a dream that lingers between waking and sleep. The spacecraft began its voyage not with haste, but with a slow, deliberate breath of motion. It had already left the blue cradle of Earth behind, slipping past the comforting glow of home and into the growing stillness that defined the outskirts of our solar system. Its instruments hummed faintly, tracing invisible boundaries of radiation and dust. The sunlight, once fierce and golden, had begun to weaken, its warmth diluted across immense distances. Each second carried the craft further into a silence so vast that even time itself seemed to slow its pace. As the years unfolded, the journey became a kind of meditation, steady, patient, and deeply solitary. The spacecraft glided through an ocean of darkness where stars burned cold and remote, and the planets behind it became whispers of memory. Signals from Earth took hours to arrive, thin threads of radio waves, stretching across billions of kilometers. What had once been a world of noise and movement was now replaced by the serene rhythm of instruments waking and sleeping, reading the quiet currents of charged particles drifting past. The sun, which had once filled the sky, was now only a bright star among many, its face too small to offer warmth. Yet its influence lingered, a faint magnetic breath that reached outward, protecting the traveler from the wild winds of the galaxy beyond. The spacecraft sensors detected the thinning of this influence, the place where the solar wind began to fade, and interstellar space waited patiently. Every reading told a story of the sun's outer limits, of its reach, its fading strength, and the gentle tug of its final whisper. The journey outward was not marked by events or encounters, but by the subtle transformation of space itself. Dust became rarer, radiation patterns shifted, and the very texture of emptiness changed. The spacecraft's instruments were sensitive enough to sense these differences, mapping an invisible landscape shaped by the sun's long exhalation. To human eyes, it might have seemed as though nothing changed at all. But to the sensors ever awake, ever watchful, the frontier was alive with delicate structure, like ripples spreading across an unseen sea. Sometimes, in the deep hours of its long mission, the spacecraft would turn slightly, angling its antenna back toward the small blue dot from which it came. The signal it sent was weak, a fragile pulse of information crossing unimaginable distances. Yet Earth always answered. That exchange, that faint electrical conversation, kept the traveler tethered to its makers. It was a reminder that even at the edge of the solar system, it was not alone. The universe was vast, but the human will to explore was vaster still. Decades passed. The spacecraft drifted farther than any object built by human hands had ever gone. Its circuits aged gracefully, designed to endure the cold and the void. Each new layer of distance added another page to a record that would outlast its builders, outlast the cities and nations that had once cheered its launch. The instruments continued to hum their quiet song, translating the unseen into data, turning emptiness into meaning. In its own way, it was still serving, still curious, still searching. The boundary between the solar system and interstellar space was not a wall, but a slow, graceful transition. Here, the solar wind, once a steady outflow of charged particles, met the resistance of the interstellar medium, a faint, thin gas that filled the spaces between the stars. The meeting of these two great flows created a region of tension and beauty, where energy danced in invisible waves. The spacecraft passed through it with quiet dignity, measuring, listening, learning. It was crossing a threshold few had ever imagined possible. In the silence, the sun's voice grew fainter, replaced by the distant murmur of the galaxy itself. Cosmic rays, unfiltered by any planet's magnetic shield, began to strike the detectors more often. Each one carried with it a whisper from faraway supernovae, remnants of stars that had lived and died long before our own. The spacecraft, a small metallic seed cast into eternity, now floated among these whispers, gathering them, turning them into messages for a world that still looked up and wondered. Light took more than 16 hours to travel from the spacecraft back to Earth. That meant that when it sent a signal, the world it had left behind was already slightly older. It was, in a sense, always looking back in time, its data a record of what the cosmos had been, not what it was now. Yet there was a strange comfort in that delay, as though the distance itself was part of the story, part of the lesson it carried. Exploration was never instant, it was a slow unfolding of patience and purpose. Sometimes, in that vastness, nothing seemed to change for months. The spacecraft drifted through regions of space where even the background hum of particles grew thin. It was a silence deeper than any human could truly comprehend, a stillness that stretched beyond imagination. Yet it was not empty of meaning. Each second carried the craft further into history, each moment expanding the frontier of human presence just a little more. To explore space was not merely to travel, it was to listen, and to wait. The mission planners had known this voyage would outlive them. They had built the spacecraft with redundancy, with grace underwear, and with a soul made of curiosity. Decades after launch, their careful work still held strong. The power output had lessened, the instruments prioritized in cycles to save energy. But even in its aging state, the spacecraft remained eloquent. Every signal it sent home was a story written in light, long, slow, but perfectly clear to those who still listened. When it first crossed the heliopause, the boundary where the solar wind gives way to the interstellar medium, it was not a sudden event. It was a quiet, gradual realization. The readings began to change, the density of charged particles rose, the sun's magnetic field fell away. The spacecraft was, at last, in another realm, no longer part of the solar bubble, but a wanderer in the open sea between the stars. Humanity had, through this small creation, touched another kind of infinity. Beyond that invisible border, the stars grew sharper, clearer. The background radiation of the galaxy, once muffled by the sun's protective winds, now reached the spacecraft sensors directly. It was as though the universe itself had drawn a curtain aside. Every measurement it sent home deepened our understanding of what lay beyond. It was still moving outward, slow and steady, but its story had entered a new chapter, one written not by propulsion, but by persistence. Time became abstract out here. The spacecraft's clock ticked steadily, but to those on Earth, the years had become decades. Generations passed while it continued its solitary arc through the void. The people who had once watched its launch were now gone, their children and grandchildren inheriting the faint signal still returning across the gulf. It had become more than a machine, it was a legacy of human endurance, a symbol of how far a single idea could travel. The data it gathered was unlike anything measured before. The cosmic environment beyond the heliosphere was dense with high-energy particles, magnetic fluctuations, and ancient dust grains. These were the building blocks of new solar systems, drifting endlessly through space. Each measurement helped scientists on Earth piece together the life cycle of stars and planets, the cosmic rhythm of birth, decay, and renewal. In that way, the spacecraft was still fulfilling its purpose: to teach, to reveal, to connect. And yet, it was not entirely untouched by time. Its power source, the tiny nuclear heart that kept it alive, weakened with each passing year. Systems were shut down one by one, carefully, so that the most essential instruments could continue. There was a quiet nobility in this fading, no rush, no despair, only the slow dimming of a traveler who had done all it was meant to do. Even as the light of its transmissions weakened, the meaning of its journey grew brighter. If one could imagine standing near it, there would be no sound, no light, only the endless glitter of stars, the faint hum of cosmic rays, and the spacecraft itself, small and steadfast, carrying the signatures of human thought into the unknown. It was not lost. It was merely continuing, far beyond where the human body could go, guided only by memory and mathematics. The universe around it did not notice, but somewhere, billions of kilometers away, hearts still listened. Sometimes, astronomers would point out where it was on a star map, just a small dot, moving ever so slightly outward. They would speak of it softly, almost reverently, as though discussing a distant ancestor who had gone on a great pilgrimage. It had no need for speed anymore. Its purpose was now endurance, its mission not motion but presence. In its silence, it told a story of patience beyond human years. The sunlight, when it reached the spacecraft now, was faint enough to be mistaken for starlight. The golden warmth that had once powered its instruments was now weaker than a candle flame. Yet that light still touched its surface, still glimmered faintly across the metal. The sun was still its origin, its compass. Even in the farthest reaches of darkness, that faint glow was a memory of home, a proof that it had come from somewhere bright, somewhere alive. The journey outward had no destination. There was no planet waiting, no orbit to enter, no final place to land. It was an open-ended voyage into the vast unknown, where distance itself became the story. And in that infinite stillness, the spacecraft continued to glide, slowly, gracefully, carrying with it the voices of Earth encoded in metal and memory. It had become not just a machine, but a message, a promise that the desire to explore would never fade. And so it goes on, further each year, into the great black sea that wraps around everything. The spacecraft, now ancient but unbroken, moves with the same calm purpose as it did on the day of launch. Around it stretch billions of stars, each with its own worlds, its own histories, its own mysteries waiting to be found. Perhaps one day, in some distant epoch, another civilization will find it, a small, silent witness to what once dreamed on a small blue world. The long, quiet journey outward is still unfolding, as slow and certain as the drift of galaxies. Its signal weakens, but the story it carries will never fade. It is the story of curiosity made real, of humanity's first breath beyond the sun's reach, of a machine that dared to wander where no living thing could go. It moves still, not because it must, but because that is what it was made to do, to continue, endlessly, outward. There comes a point, far beyond the outermost planets, where the sun's breath begins to fade, and something new begins to whisper back. This place is called the heliopause, the boundary where the solar wind meets the thin wind of the galaxy itself. It is not a wall you could see or touch, but a transition, a region where two vast and invisible seas collide. On one side lies the gentle warmth of the sun's influence, on the other, the cold and ancient flow of interstellar space. It is the edge of home, where one wind ends and another begins. The solar wind, after traveling billions of kilometers, slows and compresses as it meets resistance from the gas and dust that fill the space between the stars. Its once speeding particles begin to lose momentum, their paths bending and curving under pressure. Here, the sun's authority falters. The outward push of its charged particles becomes equal to the inward pressure of the galactic medium. This balance is delicate, shifting with solar cycles and the quiet rhythms of the universe. Imagine drifting through this region, an ocean without sound, where invisible tides meet. On one side, the plasma from the sun, hot and swift; on the other, the ancient gas that has drifted through the galaxy for eons. Where they meet, the energies mingle and swirl like smoke. The place glows faintly in radio frequencies, not with visible light but with signatures of change: electrons slowed, protons rebounded, waves of pressure echoing across cosmic silence. Voyager 1, that small and aging traveler, reached this border in 2012. Its instruments felt the difference not as a sudden barrier but as a gradual transition. The sun's particles grew scarcer, and the signals of interstellar matter grew stronger. For the first time, a human-made object tasted the air of another domain, the space between stars. Voyager did not cross into emptiness, but into something older and denser, where the influence of the sun no longer reached unchallenged. Scientists describe the heliopause as the skin of the solar system, a fragile layer where inside and outside coexist. Within it, the sun's magnetic field stretches outward, wrapping the planets in protection. Beyond it, that field bends and twists under the immense pressure of the galactic wind. Like two great breaths meeting, their contact creates turbulence, waves, and eddies of magnetic energy that ripple through the void. It is not easy to define exactly where one wind ends and the other begins. The heliopause breathes, expanding and contracting with the rhythm of solar activity. During times of strong solar wind, it pushes outward, growing slightly larger. During quiet years, it shrinks inward, as the galactic pressure presses back. This cosmic inhaling and exhaling continues endlessly, unseen, as the sun lives and changes. To understand the heliopause is to understand the limits of the sun's power. Within it, every atom is touched by solar energy, every field line shaped by its magnetism. Beyond it lies a realm where the galaxy takes over, where radiation from distant stars and cosmic rays travel freely. It is the frontier where human exploration shifts from the familiar domain of our star to the great unknown beyond. Voyager's journey revealed that the heliopause is not silent, it is alive with interaction. Shock waves from solar eruptions can reach this boundary years after they leave the sun, striking it and sending ripples back toward the inner system. These echoes travel at the speed of plasma waves, carrying information about the sun's moods even across billions of kilometers. The heliopause is, in a sense, a distant mirror, one that trembles when the sun sighs. Beyond it, the density of plasma increases. The interstellar medium, though faint by earthly standards, is thicker than the vacuum of the heliosphere. Voyager's instruments detected the hum of interstellar plasma oscillations, a faint vibration like the cosmic equivalent of wind chimes, whispering in frequencies no human ear could hear. That hum told scientists they had truly left the sun's domain and entered the galactic sea. The heliopause also protects us from much of the galaxy's harshness. Cosmic rays, high-energy particles born from exploding stars, are deflected or slowed by the heliosphere before they can reach Earth. Without this vast magnetic shield, life on our planet would be exposed to far greater radiation. So, even at this far boundary, where the sun's breath weakens, its guardianship remains. The heliopause marks not only an ending but also the last reach of its protection. Think of it as the edge of a great bubble. Inside, the solar wind keeps things calm, ordered, and relatively shielded. Outside, chaos reigns, particles from supernovae, charged dust from long-dead stars, the faint pressure of the galactic current. The boundary between them is not hard but blurred, shaped by both forces at once. It moves like the surface of a tide, sometimes calm, sometimes stormy, depending on the tempers of the winds. In its vastness, the heliopause is unimaginably distant, over 18 billion kilometers from the sun. Yet, compared to the distances between stars, it is still close. Beyond it lies interstellar space, where no sunlight warms and no planet orbits. Voyager continues to drift there, its instruments faint but steady, sending whispers back across decades and distance. Its journey gives us a glimpse into that meeting of winds, that soft, invisible border between two infinities. The meeting of winds also creates a bow wave, an area where the interstellar medium slows as it approaches the heliosphere, like air bending around a ship's hull. This bow region, though not as dramatic as the wake of a boat, still carries a subtle beauty. It marks the sun's passage through the galaxy, showing how our solar system moves like a glowing vessel through a vast and silent ocean. The particles in this region are not still, they swirl and tangle under the influence of magnetic fields. As the sun's wind presses outward, it deflects interstellar particles, changing their paths and sometimes trapping them. This interaction generates faint emissions, which astronomers detect as radio signals. These signals, soft and persistent, help map the unseen edges of our solar domain, a portrait painted not in light, but in invisible waves. Even though we cannot see the heliopause, it defines our cosmic identity. It is the line between us and the rest. Inside it, everything is part of the sun's family: planets, moons, comets, and dust. Beyond it, the galaxy begins. To cross this threshold, as Voyager did, is to step into true interstellar space, where the sun becomes just another star among countless others, small and distant, its breath no longer the strongest around. In poetic sense, the heliopause is a sigh frozen in time. It is where the sun's long exhalation slows and mingles with the soft inhalation of the galaxy. Neither wins, neither fades. They simply blend, forming a quiet equilibrium that lasts for millions of years. The energy here is delicate, like the calm at dawn between night and morning, a cosmic stillness that marks both continuity and change. From Earth, we will never see it directly, but we can imagine its beauty. Picture a great shimmering veil, invisible yet vast, gently rippling as two immense forces meet. Beyond that veil lies mystery, the unknown energies of the galaxy, drifting freely. Within it, the familiar warmth of the sun still lingers, protecting all that was born under its light. The heliopause is the frontier of comfort, the edge of the known sky. When scientists first modeled this region, they thought it would be sharp and distinct, but Voyager showed otherwise. The boundary was soft, layered, and shifting, full of turbulence and motion. It was not a fixed line but a living zone, shaped by changing conditions. Like waves meeting on a quiet shore, the two winds blended gradually, whispering across the darkness in patterns that no human eye could ever see. Even now, the sun's influence extends slightly beyond the heliopause. Its magnetic field, stretched and twisted, continues to interact with the interstellar field, creating a complex network of currents and eddies. The meeting of these two fields can spark tiny bursts of energy, microscopic flares in the vacuum, brief but constant. It is a reminder that even here, at the edge of the known, there is motion, heat, and lifelike rhythm. Voyager's instruments, though aging, still record the faint signals from this region. They hear the changes in plasma density, the whispers of distant waves. These are the sounds of the frontier, the quiet music of the heliopause. Each fluctuation tells us something about how the solar system breathes, how it interacts with the larger galaxy around it. In that data, scientists hear not silence, but conversation. To think of this boundary is to feel wonder. The heliopause is not just a physical place, it is a symbol of transition, of limits, and beyond. It marks where our sun's story ends and the galaxy's begins. The meeting of two winds reminds us that even in emptiness, there is connection, and even in distance, there is continuity. Every breath of the sun eventually meets the breath of other stars, merging into the shared pulse of the universe. And so, the heliopause stands as a kind of cosmic horizon, ever shifting, ever real. Beyond it lies the unknown, but also belonging, a reminder that the sun, for all its warmth and power, is part of something greater. Voyager continues its drift through that borderland, carrying our curiosity with it, listening to where two winds meet and whisper in eternal balance. When Voyager crossed what scientists expected to be a gradual transition into interstellar space, it instead found something astonishing: a thin, glowing layer of gas, hotter than anything its designers had imagined. This region was not dense or dramatic in appearance, yet it shimmered invisibly with energy, a place where the solar wind slowed, compressed, and met the cooler, more ancient material drifting between the stars. It was as if the sun's final breath met resistance there, forming a boundary neither solid nor empty, but fiercely alive. The data came slowly, bit by bit, across the 19 billion kilometer gulf. Instruments still functioning after decades began to detect higher temperatures than predicted, around 50,000 degrees. Not the kind of heat that would burn, but a diffuse, energetic heat spread through atoms moving at unimaginable speeds. For years, astronomers had theorized that the boundary would be calm, a soft blending of solar and interstellar gases. Yet Voyager's sensors told a different story, a fiery transition, thin but potent, like a shimmering veil between two realities. This hot, thin layer was more than just a curiosity. It revealed that the sun's reach was both stronger and stranger than we thought. The solar wind, traveling outward from the sun for billions of kilometers, did not simply fade into interstellar space. It piled up, slowed down, and heated dramatically as it met the pressure of the interstellar medium. Voyager's instruments could feel the sudden shift in particle density, the tremor of change that meant it was crossing into something entirely new, a cosmic frontier glowing with invisible fire. Scientists were surprised not only by the temperature but by its persistence. They had imagined a quick crossing, a few days or weeks of transition. But Voyager remained in this region for months, even years, suggesting that the boundary was not a thin line but a vast, turbulent shell. It was as though the sun's magnetic field, twisting and bending through space, had created a shield of compressed plasma, thin like smoke, yet powerful enough to glow with energy far beyond what had been expected. Each time Voyager's sensors registered a fluctuation, Earth-based scientists leaned closer, decoding the whispers from the edge. What they found was elegant chaos, charged particles trapped and accelerated by magnetic fields, shock waves rippling through the plasma, and temperatures that defied every prediction. This was not a simple barrier, it was a dynamic interface, alive with motion. The spacecraft was, unknowingly, gliding through a cosmic storm frozen in slow motion, where the breath of our star met the chill of the galactic sea. The heat itself puzzled researchers. There was not enough matter in that region to produce such temperatures by collision alone. Instead, it seemed to be caused by magnetic interactions, vast waves of electromagnetic energy compressing and heating particles as they slowed down. The solar wind, weakened but still fierce, collided with the opposing interstellar pressure, and energy was released like sparks between two great, invisible tides. Voyager had wandered into a place where even emptiness could burn. To imagine this region, one must think in terms of scale beyond human sense. The hot layer stretched for billions of kilometers, yet its density was so low that a human standing there, if that were even possible, would feel nothing at all. It was a paradox of the cosmos, intensely energetic, yet utterly intangible. The heat was not heat in the familiar sense, but a measure of motion, of ions racing faster than the mind could conceive. The spacecraft floated silently through this feverish calm, its sensors recording the heartbeat of space itself. Voyager's instruments detected a sharp increase in plasma density just before the transition. It was as if the spacecraft had brushed against the edge of a vast bubble, the sun's protective cocoon known as the heliosphere. The pressure outside was greater than expected, pressing inward, while the solar wind pushed outward with weakening strength. Between them lay this extraordinary zone of friction, a cosmic balancing act frozen in equilibrium, where energy was traded but never lost. Over time, scientists began to see this layer not as a mere obstacle, but as a living boundary, one that pulsed and changed with solar activity. When solar storms erupted, their effects rippled outward, reaching this far frontier years later. The temperature and particle flows shifted, reshaping the hot layer like waves rearranging sand on a beach. Voyager, patient and enduring, measured each subtle variation, its antennas whispering the results home to a world that had never stopped listening. To the human imagination, it became easy to picture this boundary as a kind of shimmering wall, a glowing curtain stretching around the sun's realm. The truth, though invisible to the eye, was even more poetic. It was not a wall that divided, but a membrane that connected, the final reach of the sun's touch mingling with the vastness beyond. Through this region, the story of our solar system met the story of the galaxy. Voyager, fragile and faithful, had become the messenger between the two. In this delicate, fiery frontier, Voyager's instruments also recorded strange fluctuations in cosmic rays. The spacecraft began detecting more high-energy particles from deep space, proving that it was nearing true interstellar territory. Yet even as it entered this new domain, traces of the sun's influence remained, like fading echoes of a parent's voice. The transition was not a clean break but a dialogue, a slow, graceful fading of one presence as another began to rise. Scientists realized that this thin layer was the sun's shield against the galaxy's harshest radiation. Without it, the inner solar system would be bombarded by cosmic rays of unfiltered intensity. It was, in essence, a protective boundary formed by the sun's own breath, a shimmering sheath of energy that had kept our worlds safe for billions of years. Voyager's passage through it was not just a scientific milestone, but a moment of quiet reverence. It was crossing the very edge of the sun's care. The region's discovery reshaped how scientists understood the heliosphere itself. They had once imagined it as a bubble with smooth edges, a gentle transition from solar to interstellar winds. Now it appeared far more complex, a wrinkled, turbulent zone filled with pockets of heat, magnetic vortices, and shockwaves. It was not uniform but alive, shaped by time, by storms, by the slow breathing of the sun. Voyager had shown that even the boundaries of our home star were wild and unpredictable. Every signal that reached Earth from this region carried not just data but awe. The tiny spacecraft, launched in the 1970s, was still rewriting textbooks in the 21st century. Its discoveries painted the sun as both powerful and fragile, a cosmic force that extended far beyond what eyes could see, yet eventually met resistance in the greater ocean of the galaxy. Voyager's survival through this volatile layer was a triumph not just of engineering, but of faith in exploration itself. To scientists, the numbers and readings told a story of plasma dynamics and magnetic reconnect ion. But to dreamers, it told a quieter story of a lonely traveler bathed in invisible heat, drifting through a glowing fog at the edge of everything we know. The spacecraft's tiny frame, hardened by decades, continued to send its messages with unwavering resolve. It had no need for light or warmth, it carried the light of knowledge instead. The 50,000-degree temperature of this layer astonished even seasoned researchers. It meant that the sun's influence extended further and more forcefully than expected. Instead of cooling gracefully, the solar wind met the interstellar medium with a final surge of heat, a last flare of vitality before fading into the galactic dark. It was as if the sun itself, sensing the limits of its reach, gave one final breath of strength before surrendering to the stars beyond. As Voyager moved deeper into the hot layer, the flow of particles around it changed direction. No longer did they radiate outward from the sun, they began to swirl and twist, aligning with the interstellar magnetic field. This marked the true beginning of the beyond. The spacecraft had crossed not a border of matter, but a border of influence, the invisible threshold between one domain and another. Humanity, through Voyager, had touched the edge of the sun's shadow. The data from this crossing took months to interpret. It revealed that the region pulsed, expanding and contracting as the sun's activity changed. It was a living interface, not a static line. At times, the boundary would move inward by millions of kilometers, then swell outward again like a breathing lung of light. Voyager's readings became the first heartbeat of interstellar space recorded by human technology, a rhythm that spoke of both creation and decay. The spacecraft's endurance through this fierce environment was a quiet miracle. Its instruments, designed for a 5-year mission, had survived almost half a century. Power levels dwindled, signals weakened, but it remained steadfast. Through the hot, thin layer, it drifted unflinchingly, gathering the last whispers of the sun's domain. In the cold vacuum beyond, it would continue to wander, a tiny ember of humanity glowing against the infinite night. From this discovery came a deeper appreciation of the sun's complexity. Our star was not merely a sphere of fire, it was a sculptor of space, shaping invisible boundaries that reached beyond imagination. The hot layer Voyager found was a cosmic fingerprint, proof that even in the quiet void, our sun left its mark, an imprint of warmth and energy written on the skin of the galaxy. It reminded us that creation itself was not contained, but expansive. Voyager's surprise reshaped our vision of cosmic boundaries. No longer could we think of the solar system as an island drifting in isolation. It was part of a vast, dynamic sea of energies and forces, where the borders between systems were blurred and breathing. The spacecraft had become the first ambassador to cross from one cosmic ocean to another, not with engines blazing, but with patience, precision, and silence. The discovery of the hot, thin layer became a metaphor as much as a finding. It spoke to the resilience of both machine and mind, the ability to endure, to discover wonder long after the expected journey had ended. Voyager's crossing proved that the universe still holds surprises even at its quietest edges. And somewhere, still moving outward, the spacecraft glides through that glowing membrane, recording the dialogue between a single star and the galaxy it calls home. In the end, this layer, invisible and immense, became a symbol of continuity. The sun's warmth did not end abruptly but faded gently into the greater warmth of the cosmos. Voyager's path through it became our path, too, a reminder that even in the emptiest reaches of space, there is connection, energy, and light. And as it continues outward, far from home, that small craft still carries a fragment of the sun's breath, burning softly in the dark. When scientists said Voyager had found a region of space reaching 50,000 degrees, it sounded like something blazing, fiery, and unbearable. Yet in truth, this heat was not what we imagine when we think of flames or burning metal. In the quiet dark beyond the planets, where atoms are so few they almost cease to exist, temperature takes on another meaning. Here, 50,000 degrees does not melt or scorch, it measures the speed of invisible particles, drifting through emptiness, rarely touching, each carrying a whisper of motion. Temperature, in human terms, is a feeling. We know warmth by touch, by the flow of energy between skin and air. But in the near void of the heliopause, there are not enough atoms to feel anything. A single cubic meter might contain only a handful of particles, far too few to warm even the thinnest thread of metal. Yet, those rare particles move with incredible speed, so fast that, if they were dense enough, they would indeed produce a searing heat. This is how 50,000 degrees is measured, not by sensation, but by motion. To the spacecraft Voyager, this strange region did not feel hot in the way of an oven or a star. Its instruments simply recorded the energies of the particles it encountered. The numbers told a story of transition, a zone where solar particles, once cooled by distance, suddenly collided with the interstellar wind. The meeting of those flows created a compression, a stirring, a kind of invisible friction that heated the plasma. It was as if two slow rivers met and made a silent, glowing turbulence. So, 50,000 degrees here is not fire, it is speed. It is the restless motion of protons and electrons jostling in nearly empty space. If you could somehow be there, you would not burn. You would feel nothing at all. The vacuum is too perfect, too thin to carry warmth to any surface. Temperature, in this distant domain, becomes a concept detached from touch, a ghostly number representing energy alone. Scientists understand this distinction deeply. They know that temperature in plasma does not mean comfort or pain, but velocity. Each charged particle moves according to the energy it carries, and when they collide, rare though those collisions are, they share that energy. So, when Voyager detected plasma at 50,000 degrees, it was detecting movement, not heat as humans experience it. The particles there are swift, not fiery. It is an elegant paradox, a place so hot that it feels infinitely cold. The particles are energetic, yet spaced so far apart that they cannot warm anything. This is the nature of space beyond the solar system, a domain where energy exists without sensation, where heat is a matter of motion, not matter itself. The human imagination struggles with this idea, for we are creatures of air and contact, and our understanding of warmth is born of closeness. When Voyager's sensors recorded this temperature, it was not through thermometers but through electric and magnetic readings. They measured how the plasma oscillated, how waves of charged particles moved across the invisible boundary. These vibrations allowed scientists to calculate the energy levels, translating them into an equivalent of degrees. The result, tens of thousands of degrees, was stunning, but the meaning was subtle. It revealed a zone of collision, not combustion. The boundary between the solar wind and the interstellar medium is like a cushion of tension. The Sun's particles, still moving outward, are met by the slower, denser gas of the galaxy. The pressure builds until it can go no further. The particles slow, their paths bend, and their energies rise. That energy is recorded as heat, though it is the kind of heat that cannot burn, a restless, radiant movement trapped in silence. Imagine standing near an invisible wall made of motion itself. You would not see it or feel it, but it would surround you with unseen energy. The particles flying by would rarely strike you, but their presence would. Hum softly through electromagnetic fields. This is the world Voyager entered, a liminal place where warmth and cold no longer have ordinary meaning, where numbers replace sensations, and light becomes something you can only measure, not see. The idea of 50,000 degrees reminds us how differently the universe behaves at great distances. On Earth, heat is dense, it travels through molecules in air and water, moving easily from one surface to another. In space, it has no such path. Without air, without contact, heat cannot spread. Each particle carries its energy in isolation, a traveler with its own invisible fire, unable to share it. The vastness of distance turns heat into silence. This number also speaks to the power of the Sun's reach. Even billions of kilometers away, the solar wind retains enough energy to collide with the galaxy's edge and create temperatures that stagger the imagination. It shows how immense the Sun's influence truly is, its breath still warm enough, after so long a journey, to stir motion in the darkness beyond the planets. This is what the 50,000 degrees tells us, that the Sun's story continues far past where light can see. Voyager's data turned that story into proof. It showed that the Sun's wind does not end abruptly but slows through a heated boundary before fading into the galactic medium. The numbers were like a fingerprint left on the skin of the universe, a pattern of motion revealing the touch of our star. It was not the kind of heat one could sense, but it marked the limit of the Sun's living breath, a faint warmth etched into infinity. Scientists often call this region the heliosheath, the layer where the solar wind slows and piles up before stopping entirely. Inside it, the plasma is turbulent, compressed, and warm by the definition of speed. This is the zone that gives rise to that staggering temperature. But the energy there is diffuse, spread so thinly that it would take centuries for a single particle to transfer its heat to another. It is a slow dance of energy without contact. If one could translate this into an image, it would not be a flame but a glow of invisible motion, a halo surrounding the solar system. In that halo, charged particles spin, twist, and ripple through magnetic waves. Their energy defines the shape of the heliosphere itself. They create the boundary's resistance, ensuring that the sun's influence fades softly, not sharply, into the galactic sea. In this way, the 50,000-degree wall is both protector and frontier. It is also, in a sense, an echo of balance. The solar wind pushes outward with its energy, while the interstellar medium pushes inward. Where they meet, energy gathers, forming that heated layer. Without it, the heliosphere would not hold its shape. The warmth of motion keeps the boundary alive, constantly renewing itself as the sun breathes and the galaxy answers. It is the warmth of equilibrium, not destruction. Even though the temperature seems extreme, the density of particles there is astonishingly low, far lower than any vacuum we can create on Earth. If you tried to put your hand into that space, you would feel nothing. There are not enough atoms to carry heat, not enough collisions to make a sensation. The warmth exists only in theory, only in speed. It is a reminder that numbers in space often describe the unseen, not the felt. When Voyager crossed this region, its instruments detected the change not by touch but through waves. The plasma outside the heliopause vibrated differently, singing in frequencies shaped by higher energy. This subtle difference told scientists they had entered a hotter region, a zone where motion was wilder, particles more restless. Yet, for all its invisible heat, it remained utterly still. No flame, no light, only the pulse of motion across the void. This paradox of extreme temperature and perfect silence captures the essence of space. The universe is full of energy but nearly empty of matter. Heat exists, but it cannot spread. Energy dances, but nothing touches. The cosmos is both alive with motion and frozen in distance. The 50,000-degree wall is a perfect embodiment of that truth, a thin veil of invisible speed separating two vast stillnesses. And this strange warmth carries a history. The particles that make up that heated layer have been traveling outward for billions of years, born in the sun's corona, flung into the solar wind, and finally slowed at the galaxy's edge. Their speed tells a story of endurance, of a journey from the heart of the sun to the quiet border of interstellar space. Every particle in that 50,000-degree plasma is a traveler at the end of an ancient voyage. When scientists speak of such temperatures, they also speak of boundaries between concepts, between heat and motion, between inside and outside, between the living breath of the sun and the endless calm of the galaxy. The heliopause's warmth is a symbolic moment of change, a place where our familiar star's energy becomes part of the wider galactic flow. The 50,000 degrees are not a barrier, but a blending, a mingling of two worlds. If you imagine Voyager drifting there, surrounded by this silent heat, you might picture it gliding through a soft haze of charged dust and light. But in reality, it is surrounded by emptiness. The heat is invisible, the particles are too few to see. Yet, through their motion, they tell the story of energy passing from one realm to another. The spacecraft feels none of it, but its sensors translate the silence into meaning. The numbers, then, are poetry in disguise, mathematical expressions of something that cannot be felt but can be known. 50,000 degrees is not about warmth, it is about persistence, energy, and the meeting of forces that never rest. It reminds us that even in darkness, there is motion, and even in cold, there is hidden heat. Space, though empty, is never still. And so, that wall at the edge of the solar system is not a wall at all, but a whisper. It is the faint glow of energy that marks where the sun's strength ends and the galaxy's begins. 50,000 degrees of motion, unburning and unseen, surrounding our cosmic home like a final breath. It is the warmth of distance, the fire of the unseen, the silent heartbeat of the sun fading into eternity. When scientists first imagined the outer edge of the solar system, they pictured a hard boundary, a kind of invisible wall where the sun's power simply stopped and the galaxy began. But what Voyager revealed was far subtler and far more poetic: a thin shell, delicate as the skin of a bubble, separating two vast oceans of space. This was not a solid barrier but a membrane, a shimmering threshold where energies intertwined. It was a place of transition, not exclusion, and its beauty lay in its fragility. The spacecraft crossed it without resistance. There was no collision, no sudden jolt, no dramatic shift that could be captured in a single moment. Instead, the change came gradually, like the fading of twilight into night. The sun's influence ebbed quietly, replaced by the hum of interstellar radiation. To those who followed its journey from Earth, the readings seemed to whisper that the universe was not divided by borders but connected by gradients, soft passages from one domain to another. In this thin shell, the solar wind slowed until it no longer carried the strength to push outward. It met the gentler but firmer pressure of the interstellar medium, forming a balance point, a kind of cosmic handshake. Instead of crashing together, these forces merged and mingled, creating a zone alive with exchange. The sun's magnetic field still flickered there, stretched thin like silk, while the interstellar field pressed gently from beyond. Voyager drifted through this quiet standoff, the peace treaty between two vast expanses. The readings from the spacecraft confirmed that the heliopause, the outer boundary of the heliosphere, was not abrupt. It was porous, dynamic, and ever-changing. It expanded and contracted as the sun breathed, pulsing with the rhythm of solar activity. At times, the boundary moved outward millions of kilometers, only to retreat when the solar wind weakened. Voyager's instruments traced these motions like a heartbeat, slow, irregular, but steady enough to mark the living edge of our star's domain. It was humbling to realize how thin that shell truly was. Compared to the immensity of the solar system, it was a hairline layer, perhaps only a few billion kilometers thick, an almost imperceptible film in cosmic scale. Yet within it, temperatures rose to tens of thousands of degrees, magnetic fields tangled and snapped, and cosmic rays shifted direction. It was a zone of transformation, where the familiar laws of the inner solar system gave way to the raw character of the galaxy itself. Voyager's crossing into interstellar space was therefore not a leap through a wall, but a slow immersion into a new sea. Each sensor on the spacecraft responded differently to the change. The plasma instruments detected denser particles, the magnetometer felt the orientation of magnetic fields twist slightly, the cosmic ray detectors began to sense more high-energy particles from beyond the sun's shield. These changes unfolded over months, not seconds, proof that the universe prefers transitions to boundaries. Scientists were fascinated by how this region acted more like a filter than a fence. The sun's outflow weakened, but it didn't vanish. Some particles still slipped through, some waves of energy still reached beyond. Likewise, cosmic radiation from the galaxy could enter, though dampened. The heliopause was a semi-transparent boundary, an energetic veil that managed both protection and exchange. It was, in every sense, alive, shaped constantly by invisible hands of pressure, magnetism, and motion. The term brick wall had once seemed appropriate, especially when Voyager first encountered the sudden rise in temperature and particle density. But deeper analysis showed that it wasn't a shock in the traditional sense. It was more like the froth that forms where two tides meet, an area of complexity rather than violence. The spacecraft sensors showed gradual, layered transitions in every measurement: density, velocity, and direction. Nature, it turned out, preferred soft boundaries, not hard stops. From the sun's perspective, this thin shell was its final frontier. Beyond it, its light and warmth would still travel endlessly, but its wind, its breath, could not. The sun's influence would fade here, its magnetic grip dissolving into the vast interstellar field. Voyager had reached that twilight zone, the place where the identity of our solar system began to dissolve into the greater identity of the galaxy. It was not an end, but a transformation, a merging rather than a separation. This realization changed the way scientists thought about cosmic environments. The universe, they saw, was not made of isolated bubbles but of overlapping layers, each breathing into the next. Every star likely carried its own shell, its own soft edge where inner winds met the greater currents of the galaxy. The heliopause was simply our version of this universal architecture, a thin, trembling skin between home and the beyond. Voyager, in crossing it, had glimpsed the pattern that connects all stars. The thin shell was not static, it shimmered with motion. Plasma waves rippled through it, caused by solar events that had left the Sun years before. These waves could compress the boundary, making it hotter and denser, before releasing it again into a calmer state. Voyager felt these waves pass by, recording their rhythm like distant thunder rolling across an unseen landscape. Through those vibrations, Earth learned that the Sun's influence could still be heard, even from billions of kilometers away. One of the most remarkable findings was that this boundary could sing. When cosmic shockwaves from solar eruptions reached the heliopause, they produced low-frequency plasma oscillations. Voyager's instruments converted these into faint sounds, thin, ghostly tones that echoed through data streams back to Earth. It was as if the boundary itself was humming, resonating with the music of the Sun. These were not metaphors but measurable waves, proof that the solar system's edge was not silent, but alive with song. That song carried deep meaning. It told scientists that the interstellar medium beyond was not empty, but filled with a whisper of matter and energy. The galaxy's own plasma, though faint, could respond to the Sun's pulses. The thin shell was where two great symphonies overlapped, the familiar tune of solar wind fading into the deeper, slower rhythm of the Milky Way. Voyager's recordings were the first notes ever captured from this meeting of cosmic orchestras. The term thin shell began to carry both scientific and poetic weight. It represented not only a discovery about physics but a truth about existence itself, that transitions are more significant than borders. Life, matter, and even starlight move through gradients, not walls. Voyager's voyage through this subtle boundary reminded humanity that the universe is continuous and endless, unfolding rather than a collection of separate domains. The spacecraft had proven connection where we once imagined separation. To understand the heliopause, one must imagine balance at its most delicate. Inside, the Sun's plasma flows outward; outside, the interstellar medium presses inward. The two pressures meet, match, and settle into an agreement, one that shifts constantly as both sides change. It's an equilibrium written not in stone but in flux, and Voyager drifted through it like a leaf through a still pond. Every measurement it took was a snapshot of harmony caught between competing infinities. The data also showed that the Sun's influence extended a little further than expected, its magnetic field lines stretching beyond the boundary, twisting and tangling with the galaxy's own. These lines didn't stop, they reconnected, forming bridges between home and beyond. Voyager had become a witness to this cosmic handshake, the place where our local bubble's magnetic threads tied into the broader fabric of the Milky Way. It was not an exit, but a weaving. To human eyes, the concept of a boundary often implies limitation. But in space, this thin shell symbolized freedom. It showed that even the smallest outflow of energy from a star could touch the galaxy and blend into its cycles. The Sun was not confined to its planets, it was part of a living network of stellar breath. Through Voyager, we saw that influence and connection are infinite, that nothing in space truly stands alone. This discovery reshaped the definition of interstellar. Voyager had not left the solar system in the ordinary sense, it had entered the region where our Sun's influence mingles with that of others. It was traveling through the communal space between stars, a realm of shared boundaries and mutual shaping. Every atom there might once have belonged to another system, another star. It was a place of cosmic recycling, where the edges of creation continually overlapped. As Voyager continued to send data from this fragile frontier, scientists refined their understanding of how thin, yet crucial, such layers are. The heliopause wasn't a wall that protected us, it was a threshold that mediated our connection to the universe. It absorbed, deflected, and exchanged energies in a balance as ancient as the sun itself. Through this understanding, humanity began to see not just where our system ends, but how it breathes into the galaxy beyond. Over time, researchers realized that this thin shell might change entirely as the sun moves through the Milky Way. Just as winds on Earth shape weather, interstellar clouds and magnetic currents shape the heliosphere. In a few million years, the solar system may encounter a denser region of space, compressing the shell tighter, altering its temperature, and changing how it interacts with the galaxy. The sun's boundary is a living structure, responsive, evolving, and endlessly adaptive. Voyager's endurance allowed scientists to observe these slow shifts firsthand. Year after year, it watched the density rise, fall, and rise again, like the gentle inhalations of the universe itself. The spacecraft had become not just a traveler but a patient witness, marking how our solar system moves within its galactic neighborhood. Its quiet persistence revealed the truth. The heliopause was not a line in space, but a living process, a slow, eternal negotiation between inner and outer forces. Even now, as Voyager continues its glide beyond that thin shell, its instruments still detect the faint whispers of both worlds, the lingering breath of the sun and the quiet murmur of the interstellar sea. It carries both signatures within its data, proof that even boundaries retain memory. In that memory lies the story of home meeting the unknown, of warmth meeting distance, of life extending its senses into the unending dark. If one could see the heliopause with human eyes, it would not appear as a wall or flame. It would be a faint glow, a soft aurora stretching around the sun's vast domain. It would shimmer gently, always in motion, always alive. Voyager passed through that glow without knowing the magnitude of its act, and in doing so, it connected humanity to the galaxy beyond. It had shown that the edge of the sun's reach was not a stop, it was a beginning. The thin shell remains, pulsing invisibly, marking where the solar wind still holds its ground. Voyager's signal, faint and delayed, continues to reach back across that distance, carrying the memory of its crossing. Each transmission is a reminder that even the most fragile boundaries can hold immense significance. The spacecraft, drifting onward into interstellar night, left behind not just data, but a revelation. The universe, vast and unknowable, is woven together by the gentlest of threads. In the end, the heliopause proved to be not a brick wall but a bridge. It is where the known and the unknown shake hands, where the heat of one world meets the calm of another. Voyager's passage through it was both literal and symbolic, humanity's step from the protective womb of its star into the wider expanse of the galaxy. The thin shell it crossed was delicate, transient, but eternal in meaning. It remains the soft boundary that unites, not divides, all that drifts beneath the stars. When Voyager crossed that shimmering boundary, the news rippled across the scientific world like the echo of a bell struck in the quietest cathedral. To most people, it was just another milestone in space exploration, but to scientists, it was something far more profound, a living glimpse into a frontier that had only existed in equations and imagination. The heliopause wasn't merely a distant place, it was a phenomenon, a glow of data, a threshold that confirmed what physicists had dreamed about for decades. It was a discovery not just of location, but of nature itself. The glow scientists speak of is not made of visible light, not something a human eye could ever see. It exists in magnetic fields, plasma waves, and subtle shifts in charged particles. When Voyager's sensors recorded these variations, it was as if the spacecraft had brushed its fingers across the edge of a cosmic curtain. Each reading shimmered with meaning, a change in particle density, a pulse in electric fields, a hum in radio frequencies. To scientists, those faint whispers were brighter than sunlight, glowing with pure information. What made this region so fascinating was how it challenged understanding. The heliopause was expected to be smoother, more defined, a neat edge between solar influence and the galaxy beyond. But Voyager revealed something wilder: turbulent flows, sudden temperature spikes, irregular pressures, and fields twisting into new patterns. It was not a clean boundary but a living one, constantly reshaped by the solar wind's pulse and the interstellar breeze. The glow, then, was not steady, it flickered, alive, unpredictable. Every instrument aboard Voyager became a kind of sense organ, feeling the universe's pulse. The magnetometer recorded the bending of fields, the plasma wave instrument detected oscillations in frequencies no ear could hear. Together, they painted a picture of an environment both serene and stormy, where energies merged and danced without sound. The heliopause glowed not in color but in rhythm, each shift a quiet heartbeat marking the sun's outer breath against the galaxy's skin. Scientists felt awe not just because of what they found, but because of what it meant about the sun's story. The heliopause confirmed that the sun's influence, though vast, was not infinite. It reached its limit here, where other stars' winds pressed in. To see that limit was to finally understand the shape of our star's power, to know where home ends. It was a revelation wrapped in calm numbers, a glow of knowledge that turned the abstract into something beautifully real. That glow is also a clue to how cosmic boundaries behave everywhere. Every star, large or small, breathes out a wind, forming its own bubble of influence. Around each of them, a heliopause exists, unseen but real, defining their domains within the galactic ocean. Voyager's crossing revealed how these boundaries might look, how energy mingles between stars. It was like glimpsing the structure of a universal heartbeat, one that beats quietly across light years. The heliopause glows, too, because of the plasma interactions within it. When charged particles from the solar wind collide with those from the interstellar medium, they create shocks, waves of compressed energy that ripple through the plasma. These shocks emit radio waves, soft and faint, but persistent. Voyager's instruments picked them up as a slow hum, a soundless tone vibrating across billions of kilometers. To scientists, that hum was a melody, a song of the boundary's living energy. It's remarkable to think that something so empty could hum with such richness. In each of those vibrations lies the story of energy exchange, of motion transformed into sound-like waves. This hum, this faint radio glow, tells scientists how dense the plasma is, how hot the region remains, how the boundary changes over time. Each note of that cosmic song holds secrets about the sun's strength, the galaxy's pressure, and the unseen weather of interstellar space. When Voyager detected that radio emission in 2020, decades after crossing the heliopause, it was a revelation all over again. The spacecraft, billions of kilometers away, was still listening, still hearing the faint chorus of charged particles vibrating in the galactic wind. The glow of scientific interest brightened once more. It proved that even in the deep silence, there is conversation, subtle, persistent, and astonishingly alive. What fascinated scientists further was how this data helped decode the larger puzzle of cosmic shielding. The heliopause isn't just an edge, it's a defense. It deflects high-energy cosmic rays, shielding the inner planets from deadly radiation. Studying it helps researchers understand how life might survive around other stars, how habitable zones are shaped not just by distance, but by the reach of stellar winds. The glow, therefore, is not only curiosity, it's a key to life itself. This knowledge glows brighter when you realize how rare such data is. No other spacecraft has ever gone this far or measured these boundaries directly. Voyager, a relic of the 1970s, continues to gift humanity with discoveries long after its intended mission ended. Its instruments are aging, its power fading, But the data it sends remains gold, each bit of information a spark in the darkness, illuminating what was once invisible. To scientists, the heliopause is a natural laboratory. It's where plasma physics meets cosmic weather, where theories are tested against the universe's oldest materials. The way particles accelerate, slow, and interact there helps explain how galaxies evolve and how stars communicate through winds. Each observation becomes a small lantern in the dark, revealing more of the cosmic map. The heliopause glows not because it burns, but because it enlightens. There is also a poetic symmetry in its glow. The sun, whose light has defined our sense of brightness for all of human history, also creates an unseen luminescence at its edge, a radiance of knowledge rather than light. Voyager's readings turned that radiance into graphs and frequencies, numbers that hum quietly but powerfully. It's as if the sun's final breath is illuminated not by photons, but by understanding. When scientists interpret those signals, they see more than data, they see beauty. They see motion and stillness coexisting, the interplay between chaos and calm. The glow of scientific interest arises from this paradox, this sense of mystery that deepens even as it clarifies. Every answer opens another question. How thick is the boundary? How does it change with solar cycles? Does it shimmer differently around other stars? The heliopause invites endless curiosity. That curiosity glows as brightly as any star. It fuels missions, models, and discussions that stretch across decades. Young scientists study Voyager's findings as if they were sacred texts, unraveling the story of our sun's outermost breath. The data hums with promise, a reminder that knowledge is not static but alive, just as the heliopause itself constantly moves, breathes, and renews. The region also glows metaphorically because it represents the meeting of human persistence and cosmic immensity. Voyager was not built for this, its creators never expected it to travel so far. Yet it endures, sending signals weaker than the flicker of a candle seen from Jupiter. That faint endurance mirrors the faint glow of the boundary it studies, fragile, but unyielding. Both are acts of persistence against vast silence. In every bit of that data, there is wonder. The glow of scientific interest is fueled by or the same or that drove ancient astronomers to look up at the stars. The heliopause, though invisible, continues that lineage. It is a symbol of how humanity reaches into the unknown, how curiosity burns quietly even at the farthest edges of light. It shows that exploration is not a matter of distance but of devotion. Even as Voyager continues, its signals grow fainter. One day, they will stop. But the glow of what it revealed will remain, reflected in research, in discovery, in the next generations of explorers. The heliopause will continue to shine in our understanding, a permanent light in the scientific sky. Its mystery ensures that we keep asking, keep imagining, keep reaching further. The heliopause glows, too, because it links disciplines. Astronomers, physicists, chemists, and engineers all find meaning in its study. It's a crossroad where every branch of science meets to understand how the sun's bubble interacts with the galactic tide. The data becomes a shared flame, warming minds from different fields. In its study, science itself becomes unified, one vast consciousness leaning closer to the universe's whisper. That unity of purpose mirrors the unity of the cosmos. Just as the solar wind meets the galactic wind, so too do human ideas meet, merge, and form something new. The glow of interest is not merely intellectual, it is emotional, communal. It is the quiet excitement shared in laboratories, the soft hum of discussion after new findings arrive. The heliopause, though far away, kindles connection here on Earth. There's a timelessness to this glow. The data Voyager sends travels for over 20 hours to reach Earth, moving through vast distances where no signal should survive. Yet it does. And when that faint transmission arrives, Scientists listen as if hearing the heartbeat of creation itself. In that act of listening lies reverence, the same reverence that made early humans watch the horizon for sunrise, waiting for the first light. Each new finding about the heliopause deepens our understanding of how stars shape their surroundings. It teaches that even boundaries, even endings, are places of transformation. The region glows because it embodies that principle, a dynamic balance between inside and outside, order and chaos, warmth and cold. It is both an end and a beginning, just as knowledge itself always circles back into mystery. The glow of interest will never fade, for the heliopause is not fixed. It breathes, shifting outward or inward as the sun changes mood. This movement ensures that it will always be a frontier, always a question that can never be fully answered. Scientists will continue to model it, dream about it, and one day, perhaps, send another Voyager to feel its pulse again. The glow will continue, dim but eternal. Even poets and philosophers find meaning in it. The idea that something so far away, so invisible, can hold such beauty in data form touches something deep in the human mind. The heliopause becomes a metaphor for understanding itself, the point where known thought meets the vast unknown, where our inner light touches the mystery beyond. Its glow, then, is both scientific and spiritual. And perhaps that is why it endures so powerfully. The glow of scientific interest in the heliopause is not about discovery alone, it's about the continuity of wonder. It reminds us that curiosity is itself a light, capable of illuminating even the darkest edges of the cosmos. Voyager showed us that even a machine, drifting silently for decades, could carry that light forward, keeping it alive where two winds meet and knowledge turns into quiet radiance. When Voyager slipped into the deep silence beyond the heliopause, scientists thought it would find peace, a stillness unbroken by the sun's restless breath. But what the spacecraft discovered was something far richer, far more alive. The space beyond was not a void, but a vast sea trembling with faint waves, electric pulses, and tiny storms that flickered invisibly through the darkness. Even in the farthest reaches, the universe was not still, it was humming, rippling, alive with energy too delicate for human senses to perceive. The data arrived on Earth as faint, stuttering streams of numbers, each pulse carrying the whisper of a distant tremor. When these signals were translated into sound, they produced eerie tones, soft and ghost-like, low hums that rose and fell, sometimes steady, sometimes bursting with a strange rhythm. These were the plasma waves of interstellar space, ripples moving through charged particles that filled the galaxy. They were evidence that even emptiness had texture, that even silence could sing. Voyager's instruments had long been sensitive to such fluctuations, but here, in the galactic sea, they found a new kind of song. Every few months, a burst would ripple through, as if the fabric of space itself had been struck by some distant hand. These were shockwaves, echoes of solar eruptions that had left the sun years before, still moving outward and colliding with the interstellar medium. The spacecraft, drifting quietly, was listening to the universe's weather. The sun's storms did not end at its visible surface. Each coronal mass ejection, each pulse of magnetic fury, traveled outward across billions of kilometers. By the time they reached Voyager, they were ghosts of their former selves, thin, faint waves of pressure pushing against the interstellar plasma. Yet even in their weakened state, they carried the story of the sun's heartbeat. Every pulse that reached the spacecraft reminded us that our star was still speaking, even from across unimaginable distance. As these waves struck, Voyager recorded brief rises in plasma density and subtle changes in magnetic field direction. It was as though the spacecraft were sailing through gentle tides, each one slightly shifting the invisible currents around it. Sometimes, the waves came in clusters, bursts of heightened activity lasting days, even weeks. Scientists called them plasma oscillations, but the term barely captured their quiet grace. They were, in essence, the breath of the sun still exhaling into the galaxy. Each event told a different story. One wave might have originated from a solar flare that erupted half a decade earlier. Another could be the echo of a coronal storm that once danced across the sun's surface like liquid fire. Space, it turned out, remembered everything. These waves carried the memory of light, the echo of creation, moving ever outward through the void. Voyager had become their listener, a lonely receiver drifting through an ocean of time-delayed whispers. The interstellar medium was not calm, as once imagined. It shimmered with hidden energy, like the surface of a lake disturbed by unseen rain. Tiny magnetic eddies swirled here and there, each born from the collision of plasma flows. Voyager's sensors occasionally detected sudden surges, tiny storms invisible to human eyes. They were not destructive but electric in nature, flashes of turbulence that rearranged the local magnetic field for brief moments before fading again into equilibrium. These storms were smaller than any on Earth, yet grander in scope. They were not confined to clouds or boundaries, but drifted freely, shaped by forces that spanned light years. Each flicker of disturbance might stretch for millions of kilometers, yet carry less energy than a lightning bolt. The scale was incomprehensible, the beauty immeasurable. Voyager, steady and silent, passed through them like a ship through fog, feeling each pulse as a faint tremor in its instruments. The waves came not only from the sun, but from the galaxy itself. Supernova remnants, shock fronts, and cosmic winds all sent out their own signals, long, slow undulations that rolled through the interstellar plasma. Some of these waves were thousands of years old, their sources long gone, their echoes still wandering. The universe, it seemed, was filled with ancient music. Voyager was simply the first instrument sensitive enough to hear it. When scientists converted these plasma oscillations into audio frequencies, the resulting tones had a haunting beauty. They rose and fell like a choir breathing in the dark, soft and shimmering. It was as though the cosmos itself had a voice, a resonance that spoke not in words but in vibration. The recordings, faint, eerie, and mesmerizing, became known as the sounds of interstellar space. They were not sounds in the traditional sense, but translations of motion into meaning. Through these signals, scientists learned that the interstellar medium was denser than expected, about 40 times denser than the region inside the heliosphere. That meant the sun's protective bubble floated in a thicker galactic ocean than we had ever realized. Each wave Voyager recorded became a probe of that density, a measure of how the galaxy pressed against the sun's invisible borders. It was a discovery that reshaped how we understood our cosmic neighborhood. These faint, rhythmic pulses also served another purpose. They helped scientists map the flow of energy across boundaries. Each wave carried clues about how far the sun's influence reached, how deeply its storms penetrated the interstellar sea. By measuring the strength and timing of these plasma ripples, researchers could reconstruct the hidden structure of space itself. Voyager, though powerless to maneuver, was mapping the unseen architecture of our galactic environment with exquisite precision. Sometimes, months would pass with no activity at all. The readings would flatten, the hum would fade, and for a while, it would seem that the universe had gone to sleep. Then, suddenly, a new pulse would arrive, a tremor stronger than before, evidence of a distant eruption reaching Voyager's position. Each one was like a heartbeat, reminding scientists that even in the coldest reaches of space, the cosmos is alive, pulsing with hidden vitality. These plasma waves also hinted at something deeper: communication across cosmic time. The waves that reached Voyager took years to travel outward, and when they arrived, their origin points had already changed or vanished. The spacecraft, in recording them, was listening to the past, a faint echo of the sun's earlier self. It was as if the universe kept its own diary and energy, and Voyager was gently reading its pages, line by line, across the stars. The tiny storms Voyager encountered weren't like weather on Earth. They didn't roar or rage. They moved quietly, governed by electric and magnetic forces, not wind or water. Yet their beauty lay in their invisibility. They were proof that even the emptiest spaces hum with structure. The boundary between calm and chaos, between void and motion, was far thinner than imagined. In every cubic centimeter of space, countless particles danced, colliding and weaving energy in silence. As the spacecraft drifted further, it began to feel less of the sun's rhythm and more of the galaxy's. The plasma waves became slower, broader, and colder in tone. They reflected the long, patient breathing of the Milky Way itself, a cosmic weather system that operated on timescales of centuries. The spacecraft was now part of something larger, a single grain floating within the interstellar symphony, listening to the quiet drumbeat of existence. The longer Voyager listened, the more it revealed about the subtle relationship between the Sun and the galaxy. The hot, thin shell of the heliopause was not an ending, but a membrane that vibrated to both worlds' music. Every wave that passed through carried both signatures, the Sun's fading pulse and the galaxy's deep hum. Voyager's recordings showed that the two were not separate but intertwined, forming a duet that extended across light years. When scientists studied these oscillations closely, they found that the interstellar medium was not smooth but clumpy, filled with regions of varying density and temperature. Each wave that Voyager detected shifted slightly depending on its surroundings, revealing that the space between stars was as complex as the air currents of Earth's atmosphere. Voyager was, in effect, feeling the texture of the galaxy, the subtle granularity of a medium once thought to be void. Occasionally, the spacecraft would pass through regions of heightened turbulence, where waves overlapped and tangled. In those moments, the instruments flickered, and data became chaotic. But within that chaos lay structure, patterns of repetition that suggested self-organizing systems. Even disorder in the universe had rhythm. The tiny storms that formed here were not random, they were part of the galaxy's natural circulation, the churning of invisible cosmic tides. The spacecraft, though silent, was patient. It recorded each fluctuation faithfully, never tiring, never failing to listen. Its endurance allowed scientists to build a long, continuous timeline of galactic weather, a record stretching for decades. Each pulse on that timeline became a chapter in humanity's story of listening to the universe. Voyager was, quite literally, hearing the breath of infinity. In the interplay of waves and storms, researchers found hints of how energy travels across interstellar space. These plasma fluctuations acted as conduits, moving momentum and heat across vast distances. They showed that space was not merely empty, it was a living, connected web of flowing energy. Through this web, stars, nebulae, and cosmic rays all shared information, a dynamic balance of giving and receiving, flowing and absorbing. Some waves Voyager detected were so faint that they barely registered, yet they held immense scientific importance. Their regularity indicated that the Sun's influence extended farther than predicted, and that its rhythm still beat faintly in the darkness. Even out here, more than 150 astronomical units away, the Sun was not silent. Its smallest tremors still resonated across the thin plasma, carried outward on invisible threads of magnetism and motion. Each discovery deepened our understanding of the cosmos as a living continuum. There were no empty spaces, only degrees of activity, scales of motion too subtle for our senses. Voyager's recordings transformed emptiness into presence. Every pulse it detected, every storm it passed, was a reminder that the vacuum was not lifeless, it was the quiet stage on which the grand performance of energy and matter unfolded endlessly. When astronomers listened to the sounds of these waves, they felt an almost spiritual awe. The tones seemed ancient, timeless, like the murmurs of the universe itself speaking in frequencies too deep for human words. In them lay the story of creation, of stars forming, exploding, and scattering their atoms into the interstellar sea. Voyager, a small artifact of humanity, had tuned itself to the rhythm of the cosmos, becoming both explorer and instrument. Over time, these measurements revealed a pattern. The waves were becoming slightly more frequent and slightly stronger. This suggested that Voyager was entering a region of denser interstellar material, a pocket within the galactic medium. The spacecraft, though powerless to steer, was venturing into a new kind of cosmic weather, an unseen cloud of charged particles drifting through space. Even at the edge of forever, discovery continued. Through it all, Voyager remained a faithful observer. It sent home its findings with the quiet persistence of a heartbeat, bridging billions of kilometers with its frail signal. Each transmission was a pulse of its own, a wave traveling across the void, mirroring the very forces it studied. The spacecraft had become what it observed, a wave crossing the endless sea, carrying the memory of home into the infinite dark. The waves, pulses, and tiny storms Voyager discovered taught humanity something profound: that stillness is an illusion. Even in the loneliest corners of space, movement endures. Energy hums. The universe, vast and ancient, is always in conversation with itself through vibrations, through light, through the gentle trembling of the cosmic sea. And there, in the middle of that eternal song, drifts Voyager, still listening, still sending back the music of the stars. In the stillness beyond planets and comets, Voyager found that even at the edge of the sun's breath, there are rhythms subtle, unseen, but undeniably alive. The heliopause does not stay still. It moves, swells, and recedes, echoing the great moods of the sun itself. Just as our star has seasons of calm and storms, its outer boundary responds in kind. The heliopause breathes with the same long rhythm, a slow cosmic heartbeat that mirrors the sun's changing power. Every 11 years, the sun enters a new cycle, its surface erupting with spots and flares, then calming again. Deep within, magnetic fields twist and realign, building to peaks of activity before unwinding into silence. These changes ripple outward through the solar wind, carried like invisible weather to the farthest edges. When they finally reach the heliopause, years later, the boundary stirs, swelling outward or collapsing inward, as though feeling the echo of the sun's pulse. This distant mirror is faint but real. Voyager's instruments, sensitive to shifts in plasma density and magnetic pressure, can feel those echoes. A stronger solar wind pushes the heliopause farther from the sun, inflating the bubble of the heliosphere. A weaker phase lets the interstellar medium press inward, compressing it slightly. These are not quick motions, they unfold over years, even decades. Yet to scientists, each one tells a story of connection, a quiet dialogue between center and edge. The sun's seasons, so familiar to us through warmth and light, have another face at this distant frontier. When solar activity peaks, waves of charged particles travel outward like storms crossing the cosmic sea. By the time they reach the heliopause, they have stretched thin, yet their power still whispers across the magnetic fields. Voyager, drifting there, becomes the listener, its antenna tuned to the faint music of solar weather played in interstellar tones. It is astonishing to think that a storm beginning near the sun, a flare lasting minutes, can affect a boundary billions of kilometers away, decades later. The heliopause responds like a distant shore touched by a tide that began long before. This vast delay in time gives scientists a window into the history of our star. By studying the motion of the heliopause, they are, in a sense, reading the sun's diary written across light years. The pattern reveals a delicate balance. When the sun is active, the heliosphere swells, forming a thicker, more protective shell around the planets. During quieter times, that shield thins slightly, letting more cosmic rays from interstellar space slip through. Even on Earth, scientists detect changes in radiation linked to these far-off cycles. It's a reminder that we live inside the sun's living atmosphere, and that its moods shape even our hidden cosmic weather. The heliopause is, therefore, more than a border, it's a mirror reflecting the sun's vitality. Its shape, its motion, and its glow all respond to the deep rhythms of magnetic change. When Voyager sends data back about shifts in plasma waves or the bending of magnetic lines, it's as if we're watching the sun's reflection ripple across a vast, invisible pond. The edge of the heliosphere becomes the sun's farthest self-image, blurred but beautiful. For scientists, measuring these changes is a way to understand the interplay between solar cycles and galactic space. They compare Voyager's findings with models of solar wind pressure, piecing together how the heliosphere expands and contracts like a living organism. In that motion lies a record of cosmic time, a breathing pattern so slow and grand that it humbles all human scales. Each expansion and retreat marks another heartbeat in the life of our star. This rhythmic motion also teaches us something about stability. The heliosphere, though in flux, never collapses entirely. It endures, adapting to each solar phase with graceful balance. The heliopause might shift by billions of kilometers, yet it remains, always forming a barrier, always mediating between inner light and outer darkness. It is a cosmic resilience, a mirror that doesn't break but bends gently, following the pulse of its maker. Even the temperature near the heliopause carries traces of these changes. When solar activity surges, energetic particles heat the boundary region, increasing plasma temperatures. As the sun quiets, those temperatures fall again. It's as though the sun's warmth, too faint to feel so far away, still leaves a fingerprint on the edge of its realm. Voyager's sensors catch that faint whisper of heat, turning it into data that glows like embers of a faraway fire. The magnetic fields tell a similar story. Each solar cycle twists the sun's global magnetic structure, reversing its polarity. These reversals ripple outward, shaping the magnetic architecture of the entire heliosphere. At the heliopause, Voyager records the slow dance of these fields, how they bend, how they merge with the galaxy's own magnetic current. The result is a cosmic ballet, where two magnetic oceans meet and trade steps. This dance is slow and soundless, unfolding over decades, but it carries profound meaning. It shows that the boundary between stars is not rigid but fluid, shifting in harmony with cycles of light and shadow. The heliopause mirrors not only the sun's physical changes but also its rhythm of renewal. Every reversal, every shift, is a reminder that change is not chaos but continuity, a steady beat marking the passage of cosmic time. Scientists often describe the heliopause as a living frontier. That phrase captures its mystery perfectly. It's not a line carved in space but a dynamic veil, one that swells and fades with the sun's pulse. Voyager, patient and enduring, keeps watch as this living border breathes. Each signal it sends home is like a reflection of sunlight glimmering on distant waves, carrying the story of how our star's spirit reaches beyond sight. Even the timing of cosmic rays reflects this mirrored relationship. During solar maximums, when the sun is active, fewer galactic particles can penetrate the heliosphere. During quiet years, more cosmic rays slip through. These changes can be detected by instruments on Earth, in orbit, and, of course, by Voyager far away. It is a vast web of cause and effect, showing how every corner of the solar system feels the rhythm of one star's magnetic heart. The heliopause, then, becomes a teacher. Through its subtle movements, we learn how stars like ours sculpt their surroundings, how their energy interacts with the greater galaxy. Each fluctuation in its boundary, each wave of plasma it reflects, becomes a lesson in stellar influence. The mirror shines not with light, but with understanding and illumination that deepens every time Voyager sends back a faint whisper of change. For humanity, this connection has a quiet poetry. We, who depend so closely on the sun for warmth and life, are also connected to its distant, invisible breath. The same cycles that shape auroras and climate on Earth also touch the heliopause. The Sun's seasons reach across billions of kilometers, binding inner and outer worlds together in a single, endless dialogue. Voyager listens to one side of that conversation, and we, on Earth, listen to the other. Even in its silence, this mirror speaks. When Voyager records a shift in plasma oscillations or a new bend in magnetic direction, it's as though the Sun is whispering to the edge, checking its reflection. The heliopause answers in turn, glowing faintly, sending signals of response. This interplay of forces, subtle yet vast, reminds scientists that nothing in the cosmos exists alone. Every point is connected through the unseen threads of energy and rhythm. Over the decades, Voyager's data has revealed not just the Sun's patterns but the patience of cosmic time itself. The expansion and contraction of the heliosphere happen slowly, too slowly for any single human lifetime to witness fully. Yet, through careful comparison, scientists glimpse those shifts, seeing how the Sun's moods ripple outward like tides across eternity. It's a humbling vision of cause and effect stretching across billions of kilometers. In this way, the heliopause becomes a cosmic clock, its movements marking the long minutes of the Sun's life. Just as tree rings tell the story of seasons past, the shape and density of the heliosphere record the Sun's ancient rhythms. Voyager, reading that record from the edge, allows humanity to look back in time not through memory, but through motion. The mirror reflects not just the present Sun, but echoes of suns long past. Each new reading carries mystery. Sometimes the data show ripples scientists cannot yet explain, shifts in plasma pressure that arrive too early or last too long. These anomalies are not flaws but reminders that the heliopause, like the Sun itself, is complex beyond easy prediction. Its reflection is imperfect but beautiful, like sunlight dancing on a rippling lake. In its distortions, we glimpse truths too subtle for equations alone. That complexity invites wonder. The heliopause does not simply reflect solar change, it also transforms it, blending it with the galactic wind's influence. The result is a reflection that is both familiar and strange, a cosmic mirror that bends light into understanding. It shows scientists how stellar winds evolve when they meet the interstellar medium, revealing a universal process that likely occurs around every star in the Milky Way. This universality deepens the meaning of Voyager's journey. By studying our own Sun's reflection, we learn how countless other stars breathe, how their seasons shape the galaxies they live in. The heliopause becomes not just a mirror of one star, but a model for all. It's a bridge between the personal and the infinite, a small spacecraft teaching us something eternal about the rhythm of creation. Even in imagination, one can feel the quiet grace of that reflection. The Sun, a blazing heart, sends its pulse outward, and billions of kilometers away, the boundary stirs, shimmering in answer. Between them lies a silence deeper than thought, yet filled with conversation. It's a cosmic dance of light and response, energy and surrender, a symmetry so vast that it feels like the universe's own meditation. The glow of this mirrored cycle is more than scientific data, it's a symbol of harmony. The heliopause teaches that every source, no matter how bright or distant, has an echo. Every force, no matter how subtle, finds reflection. It reminds us that the Sun's story is not told only in light, but also in silence, in patience, in the slow rhythm of expansion and rest. In that rhythm, we can almost hear the sigh of the cosmos breathing. Voyager continues to drift within this mirrored dance, its instruments tracing each small variation, its antenna turned homeward. Though its power wanes, it still records the Sun's reflection in the farthest dark. One day, the signal will fade, but the record it has made, the map of how the Sun's pulse echoes through space, will endure, shining quietly in data and memory alike. In the end, the heliopause stands as a distant looking glass, showing the Sun not as it appears in brilliance, but as it lives in influence. Its mirrored seasons tell us that the sun's reach is not bound by sight, that even in darkness, its rhythm continues. Through Voyager's steady gaze, we've come to see that space itself remembers light, that even where the sun no longer shines, its seasons still return, softly mirrored in the stillness beyond. Out there, beyond the planets, beyond the faint whispers of comets, the warmth of the sun no longer shines as heat or light. Yet something still moves, something fierce, invisible, and alive. The space around the heliopause is not aflame, though it burns in a different way. It is not a fire made of flame and oxygen, but a racing of particles, charged bits of matter hurled outward by the sun's endless breath, meeting the colder, stranger winds of the galaxy. When Voyager recorded that astonishing temperature, 50,000 degrees, it did not mean that the space there could scorch or glow like embers. Heat, in this deep context, is motion. Each particle, moving at unimaginable speeds, carries energy within its dance. But there are so few of them, so few atoms drifting through that immense dark, that even with their fevered motion, the region remains colder than any desert night. The heat exists only in their restless movement, not in warmth as humans know it. Scientists often remind us that temperature, in this sense, is not about touch, it's about velocity. The faster these particles race, the hotter the plasma appears, even though no hand, no surface, could feel it. In that near-empty expanse, each ion travels miles before meeting another, a lonely runner in a marathon of silence. Yet collectively, their motion forms a storm, a pulse of speed and force that defines the sun's distant frontier. That is the true meaning of the 50,000-degree wall. It is a boundary alive with racing particles, each one a messenger from the solar wind, carrying the signature of the sun's distant energy. When these particles meet the interstellar medium, they collide not with fire but with tension, magnetic lines twisting, energies exchanging, atoms slowing and then rebounding. It is a frictionless turbulence, more like music than heat, a vibration of motion without flame. Voyager's instruments caught this orchestra of energy in data, numbers and waveforms, showing how fast, how dense, how electric that region had become. There, the solar wind slows to a crawl, meeting resistance from the galactic wind that presses inward. The particles, once racing freely from the sun, suddenly feel the drag of another realm. They pile up, compressing like air against a mountain range, creating a region dense enough to glow not in light, but in radiation and plasma waves. Imagine a wind that travels for billions of kilometers, steady and unstoppable, suddenly meeting another just as vast. The result is not an explosion but a shimmer, a standing wave of force, where motion balances against motion. That is what Voyager found, the aleo sheath, the sun's outermost cushion, a sea of charged particles caught between two empires of energy. It's there that temperatures spike, not from burning, but from the kinetic struggle between forces older than Earth itself. Each particle carries a story of origin. Some were born in the sun's corona, flung outward by solar flares decades ago. Others drift in from beyond, relics of ancient supernovae, fragments of stars that died long before our own system formed. At the heliopause, these travelers meet. Their collision is not destructive but transformative. Energies mix, velocities alter, and the plasma becomes a living mosaic of the sun's breath and the galaxy's reply. To the instruments aboard Voyager, this collision appeared as a symphony of changes. Magnetic fields twisted, plasma waves pulsed faster, electron densities rose and fell. What might seem chaotic at first glance revealed patterns, fluctuations that mirrored the rhythm of solar activity. The sun's distant heartbeat could be felt even there, through the motion of these racing particles, reminding scientists that even at the edge of influence, connection endures. The phrase "not fire, but a racing of particles" captures the beauty of this paradox. The boundary glows in energy yet remains invisible. It roars with speed but whispers in silence. It's a reminder that the universe is not made of flame, but of motion and charge, forces invisible to sight but fundamental to existence. Voyager's readings gave humanity the chance to see motion itself as a form of light, to hear energy as a kind of music. Each proton and electron in that region moves with purpose, guided by magnetic fields that twist like invisible rivers. They accelerate, decelerate, rebound, and flow, never resting, never cooling. Their dance defines the structure of space itself. Scientists model these flows like weather systems, mapping eddies and waves that ripple across the boundary. It is space weather, vast and delicate, each motion shaping the shield that keeps our solar system safe. These particles are not random. They respond to laws as ancient as creation, the Lorentz forces that bend their paths, the pressure balances that hold them in motion. The heliopause is a workshop of those laws, a place where motion and magnetism shape one another. Voyager's sensors turned those invisible interactions into data lines, revealing how cosmic physics performs its grand experiment, not in laboratories, but across the unfathomable expanse of interstellar space. At 50,000 degrees, the region's plasma behaves differently than anything found near Earth. Atoms strip apart into ions and electrons, forming a conductive sea where electric currents can flow freely. These currents generate magnetic waves, which in turn guide the particles' paths. It's a feedback loop of energy and structure, a vast, self-sustaining system without walls, without flame, yet alive with racing motion. The glow of this region comes from that constant exchange. Electrons, moving fast, collide with ions and produce faint emissions, radiation not visible to the eye but measurable to Voyager's instruments. These are the whispers of motion, the signatures of speed. They tell scientists how dense the region is, how far the sun's influence stretches, and where interstellar space truly begins. It's as if the edge of the solar system hums softly, revealing its own boundary through soundless music. There's a calm elegance in this kind of heat. It is not destructive but sustaining, the balance point between forces that must coexist. The heliopause does not consume, it moderates. It turns violent motion into graceful equilibrium, converting chaos into structure. The 50,000-degree plasma becomes the universe's compromise, too energetic to be still, too sparse to ignite, yet perfect in its quiet tension. When Voyager first sensed that boundary, scientists were surprised not by its existence but by its complexity. They had imagined something sharp, like a wall. Instead, they found a region that behaves more like a tide, flowing, bending, breathing. The racing particles slow down, then surge again, depending on the pulse of the solar wind. It is a living edge, not a fixed one, a constant negotiation between two cosmic powers. The idea of racing also holds a hidden poetry. These particles have been traveling for decades, some for centuries, their speeds unimaginable, yet they never tire. They are the sun's messengers, carrying its energy outward long after the light that left with them has faded. When they finally meet the galactic wind, it's like two songs blending in the vast silence, a duet of motion and endurance. Every time Voyager records a fluctuation in particle speed or density, it captures a moment in that endless race. Sometimes the readings surge unexpectedly, revealing that the sun has sent another wave of energy outward. At other times, the values drop, showing the quiet lull between storms. In those changes lies the heartbeat of the solar system, stretched thin but still audible at the very edge of space. Scientists often call this plasma a hot wall, though that phrase hides its true nature. It is not a wall of matter, but of motion. It is made of streams of ions colliding gently, never touching in the human sense. The heat we measure is their speed, not their closeness. That makes the heliopause one of the strangest forms of boundary ever found, solid in influence, but empty in substance. Even the direction of these particles tells a story. Some are deflected back toward the sun, bouncing off the compressed magnetic fields. Others escape, slipping into interstellar space, never to return. This balance of escape and reflection shapes the very size of the heliosphere. Voyager, by measuring these pathways, allows scientists to see how the sun's breath gradually fades into the galactic breeze. There's a haunting beauty in the idea that so much energy exists in such emptiness. The density of that region is astonishingly low, fewer particles than in the best vacuums ever made on Earth, yet each one moves with energy that could melt steel if gathered together. It's a paradox of abundance within scarcity, of furious motion within stillness. Space, it seems, burns without flame. The racing of particles also has a deeper meaning in the context of time. The particles Voyager measures today may have begun their journey from the Sun decades ago. In that sense, the data we receive is not just a snapshot of space, but a memory of the Sun's past. Each ion carries history in its speed, a fragment of an ancient solar wind that has traveled for a human lifetime before arriving at the edge. Voyager's detectors, small and patient, catch those ancient travelers as they rush by. Each detection is a whisper of the sun's forgotten breath, a story told in kinetic energy. The spacecraft translates these invisible races into graphs and signals, giving form to what otherwise would remain unseen. Through it, we glimpse the living motion of the universe, the endless running of particles through void and time. And in that motion lies a truth: the universe is never still. Even where light fades, even where heat cannot be felt, energy remains in motion, racing through the dark. The heliopause, that faint border at the edge of our solar system, becomes a symbol of that persistence. It is the place where motion refuses to end, where the sun's influence lingers not in light, but in speed. Scientists studying this region speak with quiet reverence. They know the data is fragile, the signals faint, yet within them lies the most direct evidence of how stars sculpt their surroundings. The heliopause teaches that heat can exist without warmth, that motion can define space itself. It redefines what hot means, showing that fire is only one expression of energy among many. To think that the sun's reach ends not in silence but in motion is profoundly humbling. Its fire may fade with distance, but its particles continue to run, to race, to dance across the edge of the galaxy. Voyager, drifting among them, becomes the witness to this eternal movement. It listens to their speed, measures their song, and carries that echo home through the darkness. Even now, decades later, those readings continue to arrive. Each bit of data is a whisper from that kinetic realm, proof that the sun's influence has not vanished but changed form. It no longer burns as heat or shines as light, it endures as motion, as racing particles spinning endlessly through space. It's a different kind of fire, one that warms only through wonder. And so, when we say that the edge of the solar system glows at 50,000 degrees, we are really saying that it lives. It vibrates, pulses, and races in endless motion. Voyager has shown us that even in the coldest, darkest corners of the cosmos, energy is never gone, it merely moves differently. The universe, it seems, is not made of stillness at all, but of eternal, graceful motion disguised as silence. When the twin spacecraft Voyager 1 and Voyager 2 were launched in 1977, they were like two seeds cast into the cosmic ocean, set adrift on slightly different tides. No one then could have imagined that decades later, both would outlast their makers and send home messages from beyond the sun's protective bubble. Their twin readings matter not just for what they measured, but for what they revealed, that the cosmos, like a great song, can sound entirely different depending on where you stand to listen. Each Voyager took its own route. Voyager 1 flew upward from the plane of the planets, toward the northern regions of the heliosphere, while Voyager 2 took the southern path. This separation, small in astronomical terms, became crucial. By the time they reached the heliopause, their different vantage points allowed scientists to see the solar system's edge from two directions at once. It was like touching both sides of a doorway, finally knowing its true shape. Voyager 1 crossed into interstellar space first, in August 2012. Its instruments recorded that dramatic drop in solar particles and a simultaneous rise in galactic ones, a clear signature of the boundary between two realms. 7 years later, Voyager 2 followed, crossing at a slightly different distance, detecting a slightly different pressure, and painting a richer, more complex picture of the heliopause. It confirmed what Voyager 1 hinted at: the Sun's bubble is not uniform, not spherical, but shaped by winds and fields unseen. The difference between their crossings became a revelation. Voyager 1, traveling northward, encountered a region where magnetic pressure was higher, the heliopause pushed inward. Voyager 2, heading south, found a smoother, gentler boundary. These contrasts told scientists that the Sun's outer shield bends and flexes, molded by the interstellar medium pressing unevenly from all sides. It was as though the solar system drifted within a soft, cosmic current, its edges rippling like fabric in a breeze. Without both voyages, we might have thought the heliopause was a simple shell. But together, they revealed its true nature: an ever-changing, asymmetrical veil, influenced by both solar and galactic forces. Each spacecraft's instruments confirmed the other's findings while adding its own flavor, its own subtle difference in temperature, particle speed, and magnetic direction. The twin datasets became two harmonizing voices, singing of the Sun's farthest frontier. The readings mattered because they gave scientists their first real, three-dimensional view of the heliosphere's edge. Before, it was theory and simulation, a model built from indirect evidence. With Voyager 1 and 2, we gained measurements from two corners of that vast envelope. Their readings, compared side by side, let researchers map the boundary's curvature, estimate its thickness, and understand how solar cycles distort it over time. It was like tracing the faint outline of a bubble floating in starlight. Voyager 1's plasma instrument had fallen silent before it crossed, but it could still sense waves caused by nearby oscillations. Voyager 2's, however, was still alive. It measured directly the density and temperature of the plasma outside the heliopause. That single difference was golden. For the first time, scientists could compare direct and indirect measurements of interstellar plasma. What Voyager 1 heard as faint echoes, Voyager 2 could feel as touch, proving the reality behind the sound. The plasma density readings confirmed what had been guessed for decades: the interstellar medium around us is not empty but softly filled with charged gas, its pressure higher than expected. Voyager 2's instruments detected a smooth rise in density, while Voyager 1's data showed sharper variations. Together, these told a story of texture, a boundary that is neither rigid nor uniform, but rippled, like a shoreline stirred by tides. The Sun's influence fades gradually, not abruptly, across that luminous divide. Even the magnetic fields measured by the two voyagers showed subtle differences. Both found that the direction of the magnetic field beyond the heliopause was surprisingly similar to the one inside, suggesting that the Sun's influence stretches farther than once believed. Yet, small deviations hinted at the galactic field tugging back, reshaping the Sun's domain. Comparing those readings helped refine models of how solar and interstellar magnetism entwine, a cosmic handshake between two vast systems. Their twin readings matter because they bring balance to the narrative of exploration. One without the other would have told an incomplete story. Voyager 1 gave us the shock of first contact, the moment of transition into interstellar space. Voyager 2 gave us context, contrast, and confirmation. Together, they transformed what was once a singular crossing into a conversation between hemispheres, revealing the heliopause not as a wall, but as a living boundary in motion. Through their twin data, scientists discovered that even the temperature of the interstellar plasma varies slightly between poles, influenced by the Sun's cycle and by surrounding galactic pressures. These subtleties matter deeply, They help predict how other stars' winds might behave, how cosmic rays travel, and how planetary systems shield themselves from harsh radiation. The Voyager's joint readings, like twin eyes, gave depth perception to humanity's understanding of space weather beyond the Sun. Even their timing revealed something beautiful. The 7-year gap between their crossings corresponds roughly to part of the Sun's magnetic cycle. This allowed scientists to see how changes in solar activity affect the heliopause's strength and reach. Voyager 1 crossed during a more compressed phase, Voyager 2 during a calmer one. Comparing them showed how the Sun's own moods ripple outward across time, shaping its farthest borders long after the storms themselves fade. The importance of their dual mission also lies in endurance. Built with 1970s technology, each spacecraft had instruments far less sensitive than modern probes. Yet, across decades, they performed flawlessly, calibrating the faintest signals, carrying memory tapes and transmitters that now operate beyond all expectation. Their longevity turned them into historians, each reading a testament to human patience and precision, stretching the meaning of a scientific lifetime. Voyager 1 and 2 also measure cosmic rays, those high-energy particles from distant supernovae that constantly bombard the solar system. When each crossed the heliopause, the sudden rise in cosmic ray intensity confirmed they had entered true interstellar space. But their readings differed subtly, showing that cosmic radiation is not evenly distributed. This unevenness hints that the heliosphere itself shapes, focuses, or deflects incoming cosmic rays differently at each pole, much like a shield with flexible edges. These insights reach far beyond curiosity. They teach us how stellar winds protect planets from dangerous radiation. They help model how life could survive in other systems, where different stars produce bubbles of varying strength. By comparing Voyager 1 and 2's readings, scientists can simulate what might happen around red dwarfs or larger suns, predicting where safe zones for life could exist amid the galaxy's energetic storms. Even the background plasma hum that Voyager 1 detected years after crossing found its echo in Voyager 2's recordings. Both spacecraft, despite their distance apart, heard the same kind of faint radio wave oscillations, though with differences in tone and timing. This confirmed that interstellar plasma is not uniform but alive with ripples, waves of motion passing slowly through the galactic medium. It's as if both Voyagers, drifting miles apart, heard the same song played on slightly different strings. These harmonies give scientists a way to measure density waves and shock fronts in interstellar space, phenomena that no human-made object had ever directly recorded. The twin readings serve as calibration points, anchoring all future models of the Sun's relationship with its galactic surroundings. In that way, Voyager 1 and 2 are not just explorers, they are instruments tuning the orchestra of the cosmos, allowing us to hear its rhythm with clarity never before possible. The differences in particle speed and pressure between the two missions also hint at local variations in the interstellar medium. Perhaps our solar system drifts through a small cloud of denser gas, or a filament of magnetic turbulence. The Voyager's readings provide the only direct evidence for such possibilities. Each new dataset refines our understanding of how the galaxy's subtle flows sculpt the shape of the Sun's protective bubble. These twin results matter, too, for how they shape humanity's next steps. Future missions, like the proposed interstellar probe, will build directly on Voyager's dual legacy, using its data to plan trajectories, predict plasma environments, and extend exploration deeper into the galactic sea. Without both Voyagers, we would not know how variable the heliopause is, how pressure changes with latitude, or how magnetic fields behave when stretched thin across cosmic scales. Even now, decades after launch, their transmissions arrive faintly, a few bits per second, crossing billions of kilometers. Voyager 1 speaks from nearly 24 billion kilometers away, Voyager 2 slightly behind. Their twin voices reach Earth after traveling over 20 hours through space. When scientists decode their data, they hear echoes not just of plasma and magnetic fields, but of human persistence, proof that curiosity itself can cross interstellar space. Together, their readings also resolve one of astronomy's long-standing mysteries, the true boundary of the Sun's influence. Before Voyager, estimates of the heliopause's distance varied wildly, from 50 to over 200 astronomical units. With the twins' crossings, we now know it lies around 120 Australian dollars, fluctuating slightly with solar pressure. That measurement anchors models of cosmic ray flow, space weather, and stellar wind behavior throughout the galaxy. Their twin paths show that the heliosphere is slightly compressed in the north and stretched in the south, giving it a comet-like shape as it moves through the interstellar medium. This asymmetry affects how cosmic radiation enters, how magnetic fields bend, and how charged particles travel toward Earth. It's an elegant proof that even something as vast as the Sun's bubble is shaped by its environment, a cosmic dialogue in motion. The Voyager's readings also remind us of the fragility of knowledge. Each instrument operates on dwindling power, each transmission weaker than the last. Scientists must choose which sensors to keep running, which to let go. Every bit of data now carries the weight of finality. That makes the comparison between the two spacecraft even more precious, a last chance to read the Sun's boundary in stereo before silence claims them both. Beyond the science, there is symbolism in their dual journey. Two identical machines, born together, wandering apart, yet still echoing one another across the stars. Their readings are like twin heartbeats, separated by light years but joined in rhythm. Each new signal from Voyager 2 complements Voyager 1's older song, weaving a harmony of endurance and discovery. In their separation, they embody unity, proof that understanding grows best when seen from more than one angle. Scientists often speak of the Voyager's twin datasets with reverence because they represent humanity's only direct measurements of interstellar space. No other mission has crossed this threshold, none will for decades to come. The two spacecraft, ancient yet alive, hold a monopoly on first-hand truth. Every new insight into the heliosphere's shape, density, and magnetic nature flows from their shared, complementary journey. Even their faint differences become invaluable clues. Why did Voyager 2 detect a smoother gradient while Voyager 1 recorded sharper turbulence? Why was the plasma temperature slightly lower in the south? These contrasts spark new models, new theories. They remind us that science thrives not on uniformity, but on variation, the spaces between data points where imagination and reason meet. Together, their readings also offer something rare, confirmation of cosmic consistency. Despite all differences, both Voyagers found similar magnetic orientations and plasma densities, proving that the Sun's influence ends gracefully, not abruptly. It reassures us that nature is coherent, that even across unimaginable distances, the laws remain steady, echoing the same physics that govern atoms, planets, and galaxies alike. Their twin readings matter most because they speak to the persistence of curiosity. Across decades, through the slow decay of power and the widening gulf of space, both Voyagers continue to serve, whispering from beyond the Sun's touch. They remind us that exploration is not a race but a vigil, a long, patient listening to the universe's quietest truths. Each signal they send home is a small light in the darkness, two candles still burning after 48 years. And perhaps, in their fading, they reveal a deeper harmony. Voyager 1, the elder, pushes farther into the unknown, while Voyager 2 lingers closer, gathering detail. Between them stretches an invisible thread, a connection that mirrors the very structure of the heliosphere they've helped us understand. Together, they form a living bridge between the known and the infinite, two voices still calling across the night, telling us what lies beyond the Sun's last breath. When the faint, rhythmic pulse from Voyager reaches Earth, it arrives not as sound but as data, thin streams of numbers, flickering across screens in NASA's deep space control rooms. Yet within those bits lies a whisper from the galaxy itself, one that scientists have learned to translate into meaning. Each fluctuation, each delicate change in frequency, carries a story about density, pressure, and the invisible ocean of plasma that surrounds us. It's not noise, it's a slow heartbeat from the edge of everything we know. Scientists have learned that even silence in space is never empty. When Voyager 1 and 2 record the soft hum of plasma oscillations, they reveal a medium alive with motion, slow waves drifting through the interstellar medium, stirred by ancient supernovae or passing cosmic breezes. By measuring how fast those waves travel, researchers can calculate the density of particles outside the sun's reach. What seems like a whisper becomes a ruler, a tool for gauging the unseen distances between atoms scattered across the dark. From these whispers, scientists also learned that interstellar space is far from uniform. Voyager's readings shift gently over time, showing that the plasma density increases and decreases in slow pulses, perhaps as the sun's influence subtly extends or contracts with its 11-year cycle. It's like watching tides on a cosmic shore, a rhythm that tells of the sun's long breath, expanding and contracting even from light years away. Those small, consistent plasma vibrations told scientists that space beyond the heliopause isn't a still void. Instead, it's a dynamic sea of energy and motion, shaped by the debris of long-dead stars and the gravitational pull of our galaxy. Voyager's instruments picked up faint variations, ripples that pass like distant thunder through this vast medium. In those tremors, researchers see the fingerprints of the Milky Way's own weather, a slow, drifting ballet of forces. By studying these data, scientists can estimate how far the heliopause moves in response to solar changes. When the sun grows active and flings out stronger solar winds, its bubble expands. When it quiets, the pressure eases and the boundary retreats. Voyager's whispers let researchers trace this breathing motion, giving them a living model of how our star protects its planets from the harsh galactic winds outside. The temperature data from Voyager 2, in particular, showed that even though the plasma is heated to nearly 50,000 degrees Fahrenheit, the energy density is so low that it feels almost cold. This paradox, high temperature, yet low heat, is a key lesson scientists learned from the whisper. It teaches that the experience of heat depends not only on temperature but on the number of particles carrying it. In the sparse expanse between stars, warmth becomes a ghostly concept. Each subtle pulse in the Voyager signal reveals how tightly or loosely packed the surrounding ions are. When the hum rises, it means the plasma is denser. When it falls, space becomes more rarefied. These fluctuations let researchers map regions of interstellar turbulence, tracing where shock waves from distant stars have stirred the medium. The whisper thus becomes a cartographer's guide, sketching an unseen landscape where gravity, radiation, and ancient explosions leave their marks. One of the most intriguing lessons is how long these signals last. A single plasma wave can travel vast distances, sometimes taking months or even years to fade. This persistence tells scientists that the interstellar medium has a kind of memory. Disturbances echo for ages, slowly smoothing out over time. It's as though space itself holds on to events, letting their vibrations drift endlessly onward, like the last notes of a song that never fully dies. The Voyager's data also allow scientists to compare interstellar conditions with what is found near other stars. By observing how plasma behaves here, at the edge of our own system, astrophysicists can infer how other stellar winds might interact with their surroundings. This comparison offers clues about which types of stars might form stable bubbles, and which might be exposed to harsh radiation, shaping whether planets there could sustain atmospheres or even life. From Voyager's whisper, scientists learned that magnetic fields are not simple or static. Instead, they twist and fold as they cross the heliopause, mingling solar and galactic influences. The data reveal moments when the magnetic orientation changes suddenly, suggesting that the heliosphere is occasionally buffeted by passing magnetic waves from the galaxy itself. These interactions help us understand cosmic shielding, how magnetic barriers protect stars and planets from energetic particles. Another quiet revelation from these signals is the way cosmic rays behave near the boundary. Voyager detected differences in cosmic ray intensity that fluctuate with changes in plasma density. This shows that the heliopause doesn't just mark a separation, it acts like a filter, modulating what enters and leaves. It teaches that even at the smallest scales, boundaries in space are not walls but gradients, zones where forces intermingle and evolve continuously. The whispers also help refine theories about our galaxy's structure. By comparing Voyager's local plasma density with astronomical observations of distant regions, scientists can confirm how typical our corner of the Milky Way really is. It appears that we live within a slightly denser interstellar cloud, a gentle region compared to the harsher environments elsewhere. This helps explain why our Sun's heliosphere is shaped as it is, pushed here, stretched there, molded by the subtle drift of cosmic matter. Each small dataset Voyager returns teaches something new about long-term changes in space weather. By observing how the heliopause fluctuates over decades, researchers can predict how galactic particles might flow into our system, influencing cosmic radiation near Earth. These predictions feed into astronaut safety models and spacecraft shielding designs. Even a faint whisper from 20 billion kilometers away can help keep future explorers safe. There's also a philosophical depth to what scientists learn. The whisper proves that even in emptiness, communication persists. The universe never truly stops speaking, it simply speaks in forms that require patience and careful translation. The Voyager's data are not just numbers, they are reminders that the cosmos hums with quiet continuity, its messages waiting for minds capable of listening slowly enough to hear. In studying these signals, scientists have developed methods to listen to other distant regions indirectly. The techniques honed on Voyager's plasma data now apply to radio observations of other stars' astrospheres. This cross-application shows how one small mission can transform astronomy's reach, allowing us to infer the invisible edges of worlds we may never touch. The whisper thus becomes universal, a key to reading the breathing of stars across the galaxy. Voyager's readings also revealed how cosmic voids and denser filaments interact. When plasma density suddenly spikes, it might mean the spacecraft is crossing into a boundary between clouds, a structure shaped by magnetism and ancient shockwaves. Mapping these transitions helps scientists visualize the large-scale texture of the galaxy, the way matter threads through space like faint silk strands woven by time. Another lesson comes from the way these signals evolve. Over years, the tone of Voyager's plasma hum changes gradually, suggesting that the spacecraft is moving through regions of subtly different pressure. Scientists use this to gauge the overall flow of the interstellar medium around the Sun, estimating its velocity and direction. From such small vibrations, they can infer the grand movement of our solar system through the galaxy's currents. Even the delay between disturbances teaches something. When a solar flare sends a shockwave outward, it takes more than a year for it to reach the heliopause. When Voyager's instruments detect the aftershocks, scientists can time the journey, confirming how fast such energy travels through the solar system. Each detected wave becomes a timestamp, proof that the Sun's influence echoes long after its light fades. Scientists also use these data to refine spacecraft engineering. Understanding how plasma behaves at the edge of interstellar space helps future missions design antennas and detectors sensitive enough to survive such extreme isolation. The whisper informs technology as much as theory, ensuring that when humanity sends another emissary into the dark, it will listen more clearly than ever before. The whispers reveal the endurance of our instruments, too. Each reading Voyager captures requires a functioning detector, power management, and transmission stability, all operating on energy less than a household light bulb. The success of decoding such faint plasma waves proves that human craftsmanship can last across cosmic scales. Scientists learn humility from this, knowing that precision can outlive its creators. Even minor anomalies in the data carry significance. When noise levels shift unexpectedly, it could mean Voyager passed through a microstructure, perhaps a filament or a small-scale magnetic eddy. Each such event adds detail to our model of the local interstellar medium. The whispers, when compared over years, begin to form a portrait of turbulence that stretches for light-years, delicate yet persistent. These long-term datasets have another benefit: they test the limits of human patience. The slow trickle of information teaches scientists to think in decades, not days. Each new transmission from Voyager arrives as a continuation of a story started before many of its current interpreters were born. In this, the whisper teaches the art of cosmic listening, that discovery is often a matter of endurance, of waiting through long silences for the faintest reply. Through the whisper, researchers also gain a sense of scale. They learn how tiny our solar system truly is compared to the galaxy's vastness. The heliopause, once thought to be the edge of everything, is merely a thin bubble within a greater sea. Voyager's message reminds them that exploration never ends, each boundary only leads to another layer of mystery. In comparing Voyager 1 and 2's ongoing signals, scientists also see differences that reflect latitude in the interstellar medium. These subtle variations provide the first hints that even at vast distances, structure persists. It is not a random fog out there, but a living pattern, organized by unseen forces. The whisper, when compared between spacecraft, becomes a duet that defines the shape of the cosmic breeze itself. Over time, these insights coalesce into new models of galactic dynamics. By merging Voyager's plasma data with observations from telescopes on Earth, astrophysicists can trace how our local region of the galaxy interacts with its surroundings. The whisper thus expands into a conversation linking direct measurement to cosmic context, connecting the smallest fluctuations to the grandest architecture. Perhaps the most moving lesson scientists learn from this whisper is that knowledge often arrives gently. The universe rarely shouts, it hums. Voyager's faint signals remind us that the most profound truths are not in explosions or collisions, but in persistence, in the way a tiny craft, far from home, can still teach an entire species about the nature of the infinite. The whisper is fragile, but its meaning endures. As time stretches onward, the signals will grow weaker, the instruments colder. Yet, even when they finally fall silent, the data they've sent will continue to teach. Scientists will study the patterns, cross-reference the intervals, and refine their understanding of the interstellar medium long after the Voyager's sleep. The whisper will not vanish, it will echo through equations, models, and imaginations for centuries to come. And so, what scientists learn from this whisper is not only about plasma or particles. They learn patience, humility, and connection. They learn that even across billions of kilometers, meaning can still flow. Voyager's hum is the sound of endurance, the quiet assurance that curiosity, once set free, never truly fades. It simply drifts farther into the night, carrying knowledge where silence once reigned. When Voyager's faint signal brushes against the antennas of Earth, it carries not just numbers or measurements, but a message, quiet, layered, and deeply human. It tells us that distance does not erase connection. Across nearly 24 billion kilometers, that whisper still finds its way back, reminding us that even in the cold vastness of space, something built by human hands can still speak. The message it brings home is more than science. It's a story of endurance, patience, and our longing to understand. Each transmission, faint as a sigh, passes through the deep space network, giant dishes listening day and night. To receive it, engineers must align machinery with astonishing precision, compensating for the curvature of Earth, the movement of planets, and even the gentle tug of the Moon. When the data arrives, it's almost a miracle of timing and persistence. Voyager's signal is not strong enough to power a light bulb, yet it carries entire worlds of meaning across the void. The message begins with proof that humanity can reach beyond its birthplace and still remain tethered to it by invisible threads. Voyager's journey shows that exploration is not abandonment, but expansion. It demonstrates how far patience can take us, how curiosity outlives its moment, traveling on through silence until it finds a new listener decades later. It is as though the spacecraft were not just exploring, but teaching us the art of quiet endurance. Through its instruments, Voyager sends stories about the sun's breath fading, about the texture of interstellar space, about the soft hum of charged particles moving in eternal rhythm. But beneath the data lies something subtler, a reflection of us. Each bite it sends home echoes our desire to know the unknown, to listen to the faintest signals, and to find meaning even in silence. Voyager's message is as emotional as it is scientific. That curiosity itself is a form of life. Every year, as its power diminishes, the spacecraft's voice grows fainter. Engineers have learned to stretch the remaining energy like a candle's final flame, shutting down heaters and instruments to preserve its heartbeat. The data it now returns may seem meager: temperature, plasma, magnetism, but together they paint a portrait of persistence. The message is not only in the numbers, but in the fact that the message still exists at all. Voyager's continued communication tells scientists that interstellar space is not an unbroken void. There are patterns, waves, and currents that move as surely as winds across an ocean. When those signals reach us, they are faint distortions, ripples from cosmic weather. To decode them requires both science and patience. And so, the message Voyager brings home teaches us that understanding the universe demands the same stillness and care as listening to a heartbeat in the dark. Embedded in the transmission is another kind of message, the reminder of time. Voyager speaks from the past. Every bit of information we receive left the spacecraft more than 20 hours earlier, traveling at the speed of light. When we hear its voice, we are hearing yesterday. It's a lesson in perspective, a quiet reminder that even light, the fastest thing in existence, cannot outrun the vastness of space. The twin Voyagers also send home a message of symmetry and difference. One whispers from the north, the other from the south, their data complementing one another like two voices in harmony. Together, they show that truth is richer when seen from more than one angle. Their readings confirm that the universe does not reveal itself to a single gaze, it opens slowly, layer by layer, when approached with patience and collaboration. Voyager's endurance teaches that simplicity can survive longer than complexity. Built with 1970s technology, its systems are straightforward, its code clean and limited, its parts designed for reliability rather than luxury. The message it carries home is that great achievements are often born from restraint, from choosing endurance over extravagance, precision over speed. It proves that elegance lies in what lasts. In its golden record, the phonograph disc fastened to its side, lies humanity's other message, a time capsule for anyone who might find it. On it are greetings in 55 languages, sounds of rain and laughter, and music from Earth's many cultures. That record speaks not to scientists but to the cosmos itself, saying, "We were here. We lived, we felt, we listened." Voyager brings home the mirror image of that gesture, the universe listening back, faintly but faithfully. As Voyager drifts farther, its data stream slows. What once arrived in minutes now takes hours. But in that delay, scientists hear something profound, the truth that communication, even across eternity, is possible if one is willing to wait. The spacecraft's message home is a masterclass in patience, proof that distance can stretch but not sever the thread between sender and receiver. Every new discovery Voyager transmits adds a line to the story of the sun's boundary, a slow, unfolding revelation about where our influence ends. But the greater message lies between those discoveries. It says that humanity, despite its brief existence, has built something capable of speaking with the stars. Voyager carries not arrogance, but humility, the knowledge that we are small, yet still able to listen and respond. Through its faint signal, Voyager also brings home the realization that the universe is gentle and fierce at once. Its data tell of plasma that burns at 50,000 degrees, yet drifts through emptiness so vast that the heat cannot harm. It speaks of turbulence that looks violent but moves in slow grace. From these paradoxes, scientists learn that the cosmos is more balanced than chaos, a harmony too large for the human ear, but audible in numbers. The spacecraft's persistence also teaches us about legacy. Every engineer who once touched Voyager's code or circuitry has moved on, yet their work continues to speak across space and time. The message Voyager brings home, then, is one of continuity, that our creations, if made with care, can outlive us, carrying the best of our intentions farther than we can travel ourselves. Each piece of data, however small, expands humanity's map of reality. Voyager tells us where the sun's protection fades, where galactic radiation begins, and how interstellar particles flow. But it also tells us something more intimate, that knowledge is not an instant revelation but a slow bloom. The message is that truth unfolds in whispers, not shouts. Voyager's signal reminds scientists that fragility and endurance can coexist. The transmitter operates on a few watts of power, yet it crosses billions of kilometers without failing. The lesson in that fact is quietly spiritual, that even the weakest voice, if steady, can travel endlessly through the dark. Its message home is not loud, but it will echo longer than any shout. In its fading hum, there is also poetry. The frequencies that once mapped Jupiter's storms now carry the signature of interstellar plasma, shifting slowly as the spacecraft glides deeper into the unknown. The music of those readings speaks not in melody but in rhythm, the rhythm of persistence, of an object still doing its work in silence. The message it brings home is one of grace through continuity. As the voyagers continue outward, they remind scientists that every boundary once considered final is just another beginning. When they passed the heliopause, it was not an ending, but an opening into a wider reality. The message returning home is that exploration is never truly finished. It simply moves from the physical to the philosophical, from what we see to what we feel in the act of reaching. Even their slow decay carries meaning. As systems shut down one by one, scientists choose which instruments to keep alive, prioritizing discovery over comfort. This process mirrors life itself, the art of letting go while still learning. The message Voyager brings home is that even decline can be purposeful, even fading can illuminate. The whispers tell researchers that the interstellar medium is not still, that it hums with ancient energy. But beneath that finding lies another truth, that silence is relative. Voyager teaches that stillness is full of motion when observed carefully enough. It brings home the idea that peace and change coexist, that the universe, like a deep breath, is always both resting and moving. Voyager's transmissions also unite generations. Young scientists now analyze data gathered before they were born. The spacecraft's longevity turns science into heritage, a relay of minds passing curiosity forward. Its message home is communal. That discovery is not owned, but shared across time. Even the imperfections in the data, the static, the fluctuations, have meaning. They reveal the limits of both the spacecraft and the universe it measures. Voyager brings home the message that imperfection is not failure, it is evidence of reality's complexity. The noise between the signals is as much a part of truth as the clarity within. In each transmission, there is also the subtle reminder of fragility, that a misalignment, a power fault, or a cosmic ray could end the conversation forever. And yet, it continues. That resilience tells us something about intention, that what we create with care can resist decay far longer than expected. Voyager's message home is hope disguised as data. The longer it travels, the more its message changes. What once described planets and moons now describes emptiness and plasma. But that shift is itself instructive. It shows that meaning evolves with context, that exploration transforms both the explorer and the listener. What Voyager brings home now is a deeper version of what it first promised, that the unknown is never barren, only waiting. In the grand scale of the cosmos, Voyager is nothing, a speck of metal adrift among billions of stars. Yet from that insignificance emerges the profound. Its signal proves that something small can still make the universe measurable. The message home, then, is one of proportion. That greatness is not in size, but in the persistence of curiosity. Even the quiet rhythm of its data transmission has become symbolic, a steady pulse that reassures those who study it. That pulse is humanity's heartbeat extended into the void. Every time it reaches Earth, it reminds us that we are still connected to something far beyond comprehension. The message it brings home is belonging, a soft affirmation that we are part of the cosmos, not separate from it. In classrooms and observatories, Voyager's story continues to inspire. Students learn not just about plasma and magnetism, but about devotion, about keeping faith in signals too faint to hear. The message it brings home is that discovery is not a moment of arrival, but a lifelong posture of listening. Even when the spacecraft finally falls silent, its last transmission will still ripple through data archives, analyzed by generations yet unborn. Long after its voice fades, its message will continue to shape how we see the universe as a place that can be both infinite and intimate at once. The echo of that message will outlast its source, carried forward by those who learned from its quiet example. And so, the message Voyager brings home, across decades and billions of miles, is ultimately one of humility and wonder. It tells us that silence can speak, that small things can endure, and that curiosity, once set in motion, becomes eternal. In its whisper, we hear not just the edge of the sun's domain, but the edge of human reach, stretching gently into forever. Somewhere far beyond the planets, where sunlight is only a dim memory and time itself feels slower, Voyager drifts. Its instruments hum faintly, powered by the last warmth of decaying plutonium, each signal weaker than the one before. Yet it still speaks. Every whisper it sends back to Earth is like a heartbeat across eternity, soft, steady, unwilling to stop. This is Voyager's soft goodnight, not an ending, but a tender fading into the quiet. The spacecraft no longer sees the sun as we do. To its distant sensors, our star is just another bright speck among millions. The warmth that once wrapped its panels has long since vanished, replaced by a chill that seeps into every wire and joint. And yet, it endures. Each tiny pulse of energy, each faint data stream that reaches home, feels like a dream of perseverance whispered across frozen light years. Voyager is not dying, it is simply falling asleep among the stars. As engineers on Earth watch its data fade, they feel both sorrow and reverence. For decades, they have listened to its voice, adjusting antennas, decoding its static, translating its silence. They know that one day, the whisper will end. But they also know that endings are only moments of transformation, that Voyager's journey does not truly stop when the signal ceases, it simply moves beyond hearing, into the infinite. The spacecraft has become a symbol not of technology, but of devotion. It reminds us that love and curiosity can take material form. Every component, every circuit, was made by human hands, tested by human patience, and sent outward by human hope. As it drifts farther, it carries the touch of those who built it, a touch that now mingles with cosmic dust, with ancient starlight, with the breath of the galaxy itself. When Voyager first left Earth, no one knew it would outlast its creators. It was designed for a 5-year mission, but its spirit refused limitation. It became a living metaphor for endurance, the idea that once curiosity takes flight, it cannot easily be contained. Now, as it coasts through the interstellar medium, it shows that life's greatest moments often echo longest in silence. Its goodnight is gentle, stretched across decades. Scientists say that one day soon, its power source will weaken to the point where even the most vital instruments must be turned off. One by one, the sensors will darken, the transmitters will cool, and the signal will stop. But that moment will not be tragic, it will be serene. Like the final light of evening slipping behind a distant horizon, Voyager's farewell will be soft, beautiful, and inevitable. As it fades, it leaves behind not emptiness but inheritance. Every discovery, the pictures of Jupiter's storms, Saturn's rings, Uranus's haze, Neptune's winds, remains etched in human memory. The data it sent has reshaped our understanding of the solar system and beyond. Even after silence comes, Voyager's work will live on in equations, in models, in stories told to generations yet unborn. Its goodnight is not the end of the story, but the beginning of its echo. For those who still track its signal, each transmission feels sacred. The faint pulse that takes over 20 hours to reach us is more than information, it's a greeting from another realm. When it arrives, it carries the feeling of distance, the slow heartbeat of time. The goodnight from Voyager is drawn out, graceful, patient, a reminder that closure need not be sudden, that beauty can last in the lingering. The spacecraft's trajectory is steady, untouched by correction. It sails through interstellar space guided by nothing but its own inertia. In that way, it has become something like a monk of the cosmos, moving without hurry, saying nothing unnecessary, simply existing in quiet dedication. Its journey speaks the language of stillness, and its goodnight hums in frequencies softer than any lullaby. One day, long after its last signal, Voyager will continue to drift silently. It may pass near distant stars, crossing the orbits of unseen worlds, its record waiting like a secret message. Perhaps one day, another intelligence will find it, dusted with ages, and wonder who sent it. And in that distant discovery, Voyager will speak again, not with radio, but with symbol, with presence, with proof that we once reached out. The golden record it carries, that fragile, shimmering disk, will outlive everything we know. It holds music and laughter, greetings and hope, the sound of waves, the cry of a baby. Even when its circuits are frozen and its transmitters dead, the record will endure. It is Voyager's eternal goodnight, a lullaby for the universe, sung on behalf of Earth. Voyager's story reminds us that endings can be kind. It will not explode or fall or crumble, it will simply drift beyond the reach of our machines. In that stillness, it finds peace. The silence it leaves behind is not absence, but serenity, the kind that follows a long, honest day's work. Its goodnight is earned, deserved, and profound. Each time its faint tone is captured by Earth's antennas, the moment is both technical and emotional. Scientists see data, dreamers hear poetry. The hum is like an old friend's voice calling across a great distance. It tells us that even as it grows cold and dim, it is still trying, still reaching, still loyal to its purpose. That is the essence of Voyager's soft goodnight. As its systems dim, engineers will send one last command, a gentle farewell, a message of gratitude. The signal will take hours to arrive, and no reply will come. Yet in that silence, something eternal will settle. Voyager will have done its work, and it will continue onward, not waiting, not looking back. In the quiet that follows, space itself will seem to hold its breath. When future generations look back, they will see in Voyager the best of us, not our wealth, not our power, but our longing to understand. They will see that we once built something meant not to conquer, but to listen. And they will know that our species, for all its noise and struggle, was capable of stillness and wonder. Voyager's goodnight will teach them the art of graceful endings. Somewhere in that fading signal, there is warmth, not from its reactors, but from intention. It was sent with love, maintained with care, and followed with patience. That warmth is what keeps its story alive. It radiates not outward, but inward, back to the hearts of those who remember why it was launched: to see, to learn, to connect. The goodnight it sends is not lonely. It drifts through a sea of starlight, through currents of dust and magnetism that glow faintly in ultraviolet and radio waves. It travels not through emptiness, but through the quiet pulse of the galaxy itself. Voyager has simply joined the rhythm of the cosmos, a rhythm older than light, quieter than dreams. Its journey helps us imagine time differently. Voyager moves through eras the way we move through days. Long after nations change, after languages evolve, after even Earth itself alters, it will still be moving. It will outlast our monuments, our cities, our stories. Its goodnight is written in eternity, a lullaby that never stops echoing. As its memory fades from the computers that once tracked it, it becomes something more, a legend. The numbers and coordinates will vanish, but the feeling will remain. It will become a myth told around telescopes and classrooms, the small craft that left home, crossed the edge of the sun's breath, and fell gently asleep beyond the stars. Voyager's silence will not be empty, it will be full of everything it taught us. It showed that curiosity could defy time, that patience could stretch across galaxies, that humility could coexist with boldness. When it finally grows quiet, it will not have vanished. It will have transformed into a symbol, one that glows faintly in the collective memory of humankind. Even now, the signals it sends are almost too faint to detect. Engineers strain their instruments to catch the last syllables of its long farewell. Each bit of data feels sacred, like the final words of a wise traveler. And each one reminds us that goodbye is not a loss, but a continuation, a passing of light from one form to another. When Voyager launched, the world was young, the Cold War tense, the stars still mostly unreachable. Now, it has outlived those fears, outlasted those divisions. It carries a message of peace, not in words, but in endurance. Its goodnight says, we can be fragile and eternal at once. We can send our dreams into the dark, and the dark will keep them. As its instruments cool, Voyager becomes quieter still. The last warmth of its generator fades like the embers of a long campfire. And yet, that ember glows on, not in metal or current, but in the hearts of those who look up at the night sky knowing that something of us is still out there, still traveling, still shining faintly. The silence that will follow its final transmission will not be cruel. It will be soft, like snow falling on untouched ground. It will carry a sense of completion, a sigh of fulfillment, not of regret. Voyager's mission will end not with a bang, but with peace. Each generation that hears its name will rediscover that stillness. Children learning about it will imagine its tiny form drifting among the stars, its golden record glinting once in starlight before vanishing. They will feel, perhaps without understanding why, a kind of comfort in that image, the comfort of knowing that humanity reached out, and the universe accepted. Its final journey, endless as it may be, is not lonely. It travels alongside cosmic rays, drifting particles, and the faint music of magnetic waves. It has joined the quiet procession of cosmic wanderers, comets, dust, photons, all moving outward in gentle unity. Voyager's goodnight is not a solitude, but a merging. And maybe that is the greatest truth it carries home, that everything, even the smallest creation, finds its way back into the whole. Voyager's soft goodnight is the sound of reunion, the human-made becoming cosmic again. It is the closing of a circle that began with a spark of curiosity and ends with timeless peace. When the last transmission is received, when the last number is decoded, Voyager will still be speaking in another language, the language of existence. Its path will say what no words can, that humanity, for a brief and beautiful moment, reached beyond itself and touched forever. That is its good night, endless, gentle, and bright.